TypeScript is one of my favorite languages. I've used it in backend services, in command line interface programs, and of course in the front end with web development. But for a lot of JavaScript or new developers, TypeScript can be intimidating. It has a syntax that perhaps is unfamiliar and may feel verbose in certain situations. The intention of this video is to give you all of the tools and understanding of TypeScript that you need in order to be able to jump into any code base and quickly refactor, modify, move around, and have a good grasp on the language. By the end of this tutorial, you will not be intimidated when you jump into a TypeScript code base. You'll be familiar with all of the different types of syntax that you may encounter. You'll understand the benefits of TypeScript, and you'll see how TypeScript is a better choice than JavaScript when working on large projects across different teams and you're looking to scale your business, project, whatever it may be. TypeScript is known as a superset of JavaScript. It means that it has all of the aspects of JavaScript in it, and in fact, JavaScript files are valid TypeScript, but it introduces a static type system as well as a number of other functionalities that I'll cover in this video. I hope that you enjoy this video, and I hope that at the end, you walk away with the confidence of knowing the TypeScript language and can refer back to this video in the future if you want to revisit some of the more advanced topics. Thanks.
In this introduction, I just want to talk about what TypeScript is, how it originated, the benefits of TypeScript, why you should use TypeScript, and then we are going to talk about some demonstrations. With respect to these demos, you don't need to follow along, just concentrate on what I'm doing on the screen to begin with, because we're going to install TypeScript in the next section, and from then on I would encourage you to code along and try to reproduce the same code as I am. But in this beginning stage, I more just want to demonstrate how transpilation works, some of the benefits of TypeScript, and what actually happens when we talk about TypeScript and its relationship to JavaScript. So just very quickly, TypeScript was developed by Microsoft starting in 2010, and then it was ultimately released in 2012. It's now, at the time of recording, at version 5.2.2. It is the stable version, and 5.2.3 is in beta, but it has become an extraordinarily popular tool for developers in the JavaScript ecosystem. We often hear that TypeScript is a superset of JavaScript, and I'm going to talk more about that through this video. Ultimately, the most important thing to mention there is that TypeScript adds on top of JavaScript a static type system, so that we can say that TypeScript is JavaScript but with syntax for types. Ultimately though, TypeScript is just a development tool, so any TypeScript that we code still needs to be transpiled into JavaScript in order to run, and I'm going to show a demonstration around that to make that abundantly clear that this is for development and JavaScript is still ultimately what runs in the browser or the V8 engine in Node, whatever environment that you're running in. That still needs to be valid JavaScript. TypeScript has many benefits. I personally found it to be a watershed moment when I'd been working on JavaScript for a few years, and then I was encouraged by other developers and contacts of mine who are successful within software to use TypeScript. And once I used it, I could really never turn back. There's an argument you could say that for smaller projects that JavaScript is still sufficient. However, I would argue that in almost all cases that TypeScript is the better option. There's two main categories of benefit that give TypeScript such a great reputation and have propelled it into the position that it's in today with respect to being one of the most popular programming languages in the world. The first is around developer productivity. We're going to see throughout this tutorial that you get the language server protocol support, so you get all of the language services when you are in your integrated development environment. If you're in VS Code or whatever it may be, then you're going to be able to look into your data structures. You're going to be able to quickly move to where you've declared types and also the variables. It's very easy to navigate the code. It's very easy to understand the data structure that you're working with, not only for your own code, but also with third-party modules that you might be using, or if you're in a large business or team, then any other code bases that you work with are going to be easier to jump into and reason about than, for example, in the case of JavaScript, where you really are flying blind until you have a good grasp of the project. And that really points to my next benefit under developer productivity, which is that because you get all of this language server support and TypeScript is giving you warnings and TypeScript is giving you errors in certain cases, it's trying to encourage us as developers to make better decisions that will catch bugs before they even get to the production environment. So while we're developing, we are detecting bugs, it's tightening up our code, and it's ensuring that the types that we're working with aren't going to result in runtime errors. So from a developer productivity standpoint, TypeScript has been a huge win within the JavaScript ecosystem. And the second is around scalability and maintainability. And I've touched on it a little bit because if you're working in a large business and you're working with JavaScript, it can be really difficult to understand and quickly get a grasp onto what you might be importing from a third-party module or any other services that you are consuming. So the scalability and maintainability, because it's self-documenting, because you've got all of the types, you can read the code and very quickly ascertain the shape of the data that you're working with, means that its maintainability is excellent. And that also leads into scalability, because now you're not going to have an issue. You're going to have a generally higher quality of code throughout your project if you're using TypeScript, because TypeScript is enforcing good code structure on you, and therefore it's going to make it more scalable. You can work more easily, as I mentioned, across teams, and people can more quickly understand the code that you've written. To get started, I'm just going to have a quick demo to show you the shortcomings of JavaScript and where TypeScript can be beneficial to us as developers. On the left-hand side, you can see this function. It's called add numbers, and it takes two parameters, A and B, and it simply adds them together. Right now, it has the value of A set to 2 and the value of B set to 2. So we can run this, and we can see that the output is obviously, as expected, going to be 4, which is being printed down here. The problem with JavaScript occurs because of the flexibility of the language, which was originally built in because of its front-end nature and the fact that we're dealing with user input and we don't always necessarily know exactly the type of user input. So our function add numbers doesn't have any explicit type declarations, and therefore will take anything into A and B without complaining. For example, let's say that A here is 2. We can see that on the left-hand side, we're not getting any warnings whatsoever. And on the right-hand side, we are, however, getting 22. The reason being that the first parameter is actually a string now. You can imagine that the user has input a string into a form, and perhaps we've forgotten to convert it into a number, or we weren't aware that we had to, or whatever it may be. And so we've ended up with a situation where actually JavaScript is doing its best. It's saying the first parameter here is a 2, and so I'm going to try and add these two together. When they're strings, I'm going to concatenate them rather than add it as a number. So we've encountered this bug, and these kind of bugs can be very difficult to debug in the JavaScript world when we're dealing with highly flexible inputs. One other thing I want to point out here is that if we hover over any of these, we can see that, for example, if we hover over A, it says down the bottom, no information available. And so JavaScript by default is not giving us any support within the IDE. If you're in VS Code, you'll be able to hover over certain variables in TypeScript, and you're going to see that this actually will give you function signatures. It'll give you information that can help you as a developer. Right now, we're not getting anything, but in a moment, we're going to rename this to be a TypeScript file, and I'm going to show you how this is a benefit to us. So let's do that. We've renamed our file, and we've done that by using a .ts extension rather than .js, and this signifies that we're now working with a TypeScript file. Right now, we're not getting any of the benefits of TypeScript because I've turned on this TS node check. If you use this at the top of your file, it'll turn all of the TypeScript off and we won't get any of the benefits of TypeScript. Okay, so for the moment, I'm just going to close that on the right hand side, and I'm going to turn off this TS node check. Now you can immediately see that TypeScript is giving us a warning. If we go to that warning, we can see that it's telling us parameter A implicitly has an any type. Any is the most flexible type. And we're going to get into all of this, so don't be intimidated right now. This is just a demo to show you some of the benefits. But basically, what it's telling us is that we need to declare the type of this variable. And so we can say that A and B are numbers. And then in this case, it now knows what to expect. So the issue that we were having before was that we were passing in a string, even though we really wanted to pass in a number and add the number to B. Well, now TypeScript is saying that argument of type string is not assignable to this parameter of type number. So it's telling us you're going to have a problem because you're passing in the wrong value type. If we turn that back into a number, we've now fixed the issue. And so you can see here the benefits of TypeScript and how it's helped us to catch a bug before we've even submitted the pull request for this feature that we might be working on. TypeScript catches a lot of these kind of bugs, and it enforces certain discipline on us, which for the most part is a good thing. By the end of this course, you won't be restricted by the type system. You'll still be able to achieve all of the outcomes that you would with JavaScript. That just comes with time and understanding how we can use the static type system to still achieve the outcomes and not feel restricted. Some beginners want to use the any type all the time. We don't need to if we understand how to declare our types, build our types, and work with types correctly. In the next step, I want to show you that when we talk about TypeScript being a superset of JavaScript, and we say that only JavaScript can be run in the runtime environment, that is to say that TypeScript isn't valid JavaScript. I want to point out what happens when we compile our TypeScript. So when we install TypeScript, which we're going to do in the next section, we get a TypeScript compiler. And what this does is it transpiles all of our TypeScript code into valid JavaScript. And it does this based on settings that we've configured in order to determine which version of JavaScript that we want to compile to, and so forth. The important part here is just to note that we need to transform our TypeScript into JavaScript so that we can run it. So let's do that now. The way that we transpile code from TypeScript into JavaScript is we use the TypeScript compiler and we pass it in the name. And so I'm going to pass that in here, and it is going to be this file, which is introduction.ts. And so this is going to transpile this TypeScript file into JavaScript. It's done. So now we can go and open that file. On the right-hand side, we've got the transpiled JavaScript. So we took our file on the left-hand side, we put it through the TypeScript compiler, and we ended up with this code which can run in a JavaScript environment, like a browser. And it depends on the settings that you've provided to TypeScript. In my case, I left it as the default, and so the version of JavaScript that we're getting is older. It means that it can run in more environments and older browsers. That's why we're seeing the var keyword for the declaration, and we're seeing the older style function syntax. But importantly, we're not seeing the additional syntax that we introduced with TypeScript, which was the number type on the parameters A and parameter B. So that's been stripped out. That's not valid JavaScript, and therefore it doesn't exist at runtime. So this is what we mean when we say that this is a developer tool. It helps us to develop our code, which we've done on the left-hand side, but ultimately it's JavaScript that runs on the right-hand side. Before we get started on this TypeScript journey, let's install TypeScript. We need to install it on the local system so that we can use it. And on the right-hand side, you'll see typescriptlang.org, which is the official website for TypeScript. It includes a lot of very useful information, particularly with respect to the documentation. There are starter guides for newcomers and also guides for programmers coming from other languages like C#, Haskell, and so forth. On the home page, you'll see this Try TypeScript Now, and we can click on that. It gives you the option to run it in the browser or otherwise on your computer. I'm going to install it locally on my machine, and down here you'll see there's the option to install TypeScript globally. In my case, I'd prefer it to be global so that I can use it on any of the projects that I'm working on. And so I simply run the command npm i-g for global TypeScript. All right, so I had it already installed, but it looks like it's updated it. We can now check that it's installed by running tsc --version. you can see here that I've got 5.2.2, which is the latest stable version at the time of recording. It's important that you have an up-to-date version because I'm going to be covering all of the modern syntax of TypeScript. So if you have an older version, some of the items may not work. It's important that you install at least 5.2. When you install TypeScript, you actually get two things. One of them is the TypeScript compiler that we just saw, but the other one is the TS server. The TS server is the TypeScript language protocol language service. It gives us all of the services within our development environment for auto completion, for giving us feedback on our types. We can see in here that if we were to make certain decisions with respect to what we're accepting in here, for example, let's say that rather than accepting string, we're accepting number, the TypeScript language service will tell us that we are passing in this string hello world, and that is not actually a valid type for the function logger. So we've got the TypeScript compiler that compiles or transpiles all of our code from TypeScript into valid JavaScript so that we can run it in different JavaScript environments. And we have the TS server, which is the TypeScript language server. That's the same language protocol server that's going to be running in VS Code, or in my case, I'm using NeoVim. Once we've got it installed, we're ready to start talking about the additional syntax that TypeScript introduces. Now that we've got TypeScript installed, it's time to introduce the TypeScript type system. The first concept that we need to understand is the concept of primitive types. And if you're coming from other languages or JavaScript, this is going to be very straightforward. Simply what we're doing here is we are restricting variables to a certain type or set of types. In this case, we've got string, number, and boolean. These are primitive types in TypeScript. And while there are a few other primitive types, these primitive types are the types that you're going to encounter 99% of the time. We can declare a variable, say a string, and then we can give it a type. In this case, we've said is a string, is a type of string, and that string that we're assigning to this variable is hello world. We can now assign other strings here. We don't get any warnings whatsoever. If, however, we said that this is a number, which is the second primitive type, we will be told by the TypeScript language service that the type that we're assigning, or the string here, hello world, is not assignable to type number. Therefore, we would need to change this to be a number. And in this case, the assignment on the second line is also not valid, but we could assign a new number. The third type, just quickly, is the Boolean type. And once again, we're being told, okay, well, the type that we're assigning, the value here, 8, is not valid in this case because is a string, which we can rather call is a bool, should be of type Boolean. So here we can simply say that that's true, and here we could change that to false. Pretty straightforward. But what about the case where we want to assign more than one type to a variable? For example, this could be a string or a number because perhaps it is instantiated as a string but later receives possibly user input, which is a number. So in this case, we can say this is a string, or this pipe symbol represents that we're going to have a union, which means that we're going to have a set of primitive types here. And we can say that this is a string or number is either of type string or it's of type number. So now we can say assign a string and it works. And if we said is a string or a number is 888, it will also not complain. But of course, if we were to assign the Boolean value of true, it would complain. One last thing to note with respect to TypeScript's primitive type system is that it will infer the type based on the usage. For example, if we said in this case that this is a string or a number, and we said hello world, if we were to hover over this string or a number, then we would see that TypeScript has determined that this is a type of string. So actually, in the vast majority of cases, it is unnecessary to declare the primitive type directly after the variable name. Of course, if we were to declare a number and we said this is 888, then we will see that is a number is of type number, and we can assign other numbers and it won't complain. TypeScript will, however, complain if, based on the instantiation of this is a string or number, we now go and say is a string or number is 8. It will say, well, we were expecting this to be a string. We've inferred that is a string or number is a string because hello world, it was instantiated with is a string. But now you're passing a number and that doesn't seem to be valid. So now in this case, if we were ever in that situation, although we would generally like to avoid, we can go back to that syntax to say this is a union. This is either going to be a number or a string. Finally, the declaration keyword is important with respect to the variable. If we use let, as we've been using until now, it will assume a broader type. So say let is a string, and we pass in the string again. We can hover over this, and it says it's of type string, because being let, we may change this variable. We may assign a different string to is a string, and therefore it's just restricting this type to string. However, if we said that this is a const, and we hover over is a string, it'll tell us now that it's an even narrower type. It's actually a string literal of hello world. Because, of course, we know in JavaScript that const means that it's a constant variable and it cannot be changed. So if I was now to go and change that string, we can see that we cannot assign is a string because it is a constant. The TypeScript server here is also giving us a few actions. So you'll see down here that we can convert this const to a let. And if I hit 1, then it will fix that issue for us. As we progress through this tutorial, you're going to see more and more useful feedback for navigation, for understanding the type and shapes of our data. And that is just one useful element of the TypeScript language services with respect to code actions. Just as in JavaScript, TypeScript has the concept of null and undefined. Recall that JavaScript is valid TypeScript, so that makes sense. And we can demonstrate the use of null and undefined here, as well as encountering the any type. The any type is something that we ordinarily want to avoid in TypeScript, and I'm going to show you what happens when you encounter it. So let's declare a variable, and we're going to say it is null. If we did this in JavaScript and we hovered over it, it would say that this is of type undefined. However, in this case, TypeScript is giving it a type of any. Any is the broadest type, meaning that it could be of type any type. This isn't useful to us because this is effectively almost identical to the original JavaScript behavior. If we said is null and we set null, which is the keyword for null, then we can now see that this is still any. And this is why if we are using the let keyword, it can be important to assign the type. I almost never use the let keyword, but it's important to understand that this is the behavior. Now if we hover over is null, you'll see that it has a type of null, and we're assigning null. I'm going to touch on and point out when we're in the type space and when we're in the value space throughout this tutorial. And this is an example of where this area after the colon, we are in the type space. This null is TypeScript syntax and indicates that this value is null. Whereas on this line is null equals null, this is in the value space. So although they're exactly the same word, the syntax is the same, it's important to understand that what occurs after the colon and what occurs after the equals is the difference between type space in this case and value space. I'm going to reiterate this over the course of this tutorial, but it will become second nature and self-explanatory by the end. There is also the type of undefined. So now we can see that this is set to undefined, and this is now complaining because we are assigning it something. I would almost never use undefined, but it is important to understand that you can assign that as a type in TypeScript. As a superset of JavaScript, TypeScript necessarily also includes the critical data structures of objects and arrays. I'm going to introduce their syntax here with respect to TypeScript. The first example is an object. I am declaring this constant variable obj as an object, and then using the colon syntax to indicate that we're now in type space, we have these curly brackets to indicate this is an object, and this object has two variables, A and B. A is a string and B is a number. Then we encounter the equals sign, which means that we're now entering the value space, and here we have A is a string of hello world and B is a number. So this is how we can declare an object in TypeScript. Secondly, we have arrays. In the case of an array, we have here a string or a number. So this is an array that could include, each element could either be a string or a number. And here you can see after the equal sign, the assignment operator of the value of the array, which is at element index 0, hello world, and at index 1, 888. What's more common than this array syntax is, however, that you will encounter such a syntax, which is saying that using these square brackets indicating that this is an array. Now, it's important to look very carefully at the way that I've written this. We've got these open brackets, and inside we have the union of string or number. This is very different, however, than writing string or number, because what this means is that this is going to be an array of strings, that is to say an array that only includes strings as its element, or an array of numbers, meaning this is an array that only includes numbers. So if we were to change this here to 777, that would be valid. If we were to introduce a string and then introduce a string, then that would also be valid. We're going to be using objects and arrays a lot, so don't be discouraged if this doesn't make sense. It's just important to understand the very basic syntax that if we want to declare a type of an array, we use these square brackets, and if we want to declare a type of object, we can use these curly braces. We have introduced primitives and also working with objects and arrays in TypeScript, and we can see how they are useful when instantiating variables or passing parameters into functions, but it would be a bit inefficient if every time we had to instantiate a new variable or pass in something to a function or a class, we had to repeat the type declaration. And so TypeScript introduces the concept of type aliases and interfaces, and this allows us to declare our own types and then reuse them throughout our code as we see fit. Most of the time, types and interfaces can achieve the same result, but there are a few differences, and we're going to cover them here and throughout the tutorial. For myself, I tend towards using type alias keyword, but you can use interfaces, and particularly if you're coming from an object-oriented background, you may feel more comfortable with interfaces. At the end of the day, it's up to you and the broader team. You can find out what works for you. But it is important to understand the syntax for each of them because you're going to encounter it in lots of different code bases. The first example I'm going to show, we're just going to create a basic shape of an employee's data set. So here we've got an employee, and this employee is simply a basic object which has a name, a salary, and a location. This is how we would declare the type in the type space of an employee. Now, if we went and declared the variable of employee, we can say employee, and here what we can do is we can say that is going to be of type employee, and therefore TypeScript, if we don't put anything in here, is going to give us an error saying that it's expecting this employee type to have a name, salary, and a location. So we can do that. We can include the name, and we can say this is Boris. We can say Boris has a salary of 100,000 perhaps, and location is, in Boris's case, we're going to say he works in London. So now TypeScript is not complaining. We're passing in all the fields that are expected in this type alias that we've declared above. We can now do the same thing though using this interface syntax. So I'm going to, rather than say use the keyword type, I'm going to use this interface keyword. Now we have an object. It's got name, salary, and location as expected fields, and we are not getting any errors from TypeScript. So you can see that with the two syntaxes in this very basic case of an employee, we're able to achieve the same outcome. There is one aspect to interfaces that I want to point out here, and in a later section of this tutorial, we're going to talk about extending either types or interfaces, so we can say take a base type and then build upon it. What I want to point out is there is a strange behavior, or at least I find it a bit quirky when it comes to the interface keyword. If we were to declare interface employee again within our code, let's say this employee has an ID and the type of this ID is going to be a number. You might say, well, we have declared this type twice in the type space, and therefore either we're going to say it's the original declaration of employee, which has these three fields, name, salary, and location, or its ID. But in fact, TypeScript, by declaring this twice, has combined the employee type. And so here, when we hover over the error, it's telling us that the property ID is missing. And here we can see that it's missing in this type name, salary, location, but requires the type ID. So imagine that you're working on a large code base, you're importing type declarations from some other part of the project or a third-party library. This could be quite confusing, and therefore it's important to be aware of this quirk, and I tend to avoid it where possible. If we were to look at types, I'm going to change this now back to being a type. If we were to declare here another type alias of employee and say that there is an ID of type number, we're now going to get an error stating that this is a duplicate identifier. So we can't do that. I'm going to touch on how we can build upon types. As I mentioned, both types and interfaces can be built upon, and that will be covered in a few sections from now. But we're going to leave that for the moment, and we're going to talk about another aspect of TypeScript, which can also be somewhat confusing, and that is excess property checking. What do I mean by excess property checking? Well, TypeScript has a system of inference. If we were to include in here another field, let's say ID, and the ID is 99, and it's not on the original declaration at the time of instantiation, using this syntax where we use this colon and then tell TypeScript what the type of this variable is going to be, then it's going to tell us that there is an excess property on this instantiated object. However, let's say we remove this and we use the TypeScript inference system, which is going to be touched on throughout this course, but you can see that TypeScript is smart enough to pick up on the type or shape of the data that we're working with, even when we haven't given it an explicit type declaration here. But now let's say we want to save this employee into another variable. So we're just going to call this saved employee, and we're going to say that this is an employee. So let's save in the employee, and now all of a sudden, if we were to add in here 99, even though there are additional properties to what we are expecting in the type employee, TypeScript is still allowing us to save it in here. This is because of TypeScript's structural type system, where TypeScript sees that this object here with an inferred type of these four fields, name, salary, location, and ID, can fulfill the original type that we're expecting in this assignment. It will allow it to proceed. It's only when we instantiate an object and use the specific, explicitly tell TypeScript that this is going to be of type employee that we get this warning for excess property checking. That is the same behavior with interfaces, and it's just something to be aware of. Just on that point, it's generally bad practice within TypeScript, for example, to declare an object and then in here say employee.name. While you may have seen this in some JavaScript projects, the initial inferred type is an empty object. So when we add on these additional variables, TypeScript is going to give us a warning, and therefore this is very bad practice. When we create an object, we want to go back to the original way that we were doing it, and we want to create that object at that time that we're instantiating it with the fields that it's going to have. If, for example, we had ID here and that was expected on the employee, but in fact wasn't on our original employee object, then we would use spreading to say, okay, we're going to have this employee here, and we're also going to have an ID, and we're going to say that that is 99. Therefore, we can fulfill it. And this circumvents that issue that we saw before, where TypeScript was giving us a warning that we're assigning new fields on an object that doesn't have those fields. Now, I've mentioned that type aliases and interfaces are for the most part interchangeable. We've talked about one quirk with respect to the interface keyword, but there are a few other differences. One of those differences that I'm going to cover here is when it comes to declaring our own types, the type alias allows us to declare useful primitive types that we could use ourselves. For example, let's say that here we have the type ID number, but we've been getting a lot of complaints within the broader business that different developers have been using a different data structure for ID. In some cases, they've been using strings. In some cases, they've been using numbers. We want to be consistent. So in a single place within the code base, we can declare a type alias, and we're going to say this is an employee ID and it's a type of string. If we hover over this, it's still just a type of string. However, we can now use it within our code to be more explicit about what we actually intend with this type. As far as TypeScript's concerned, for all intents and purposes, this is still just a string. As developers, this is a helpful tool to make our code more readable and easier to reason about. Now, down the bottom, we are getting an error to say that this is expected to be a string, and therefore I'm going to change it to be a string. So another thing that we can do with type aliases that we can't do with interfaces is that we can have something like locations, and in here we might have two offices within our company, and that might be London and, let's say, Berlin. Now all of a sudden we've declared this union of types, and if we hover over it, it's expecting these two string literals. So rather than just having a string here in location, we can now say that we've got this locations type, and now we can see that location is incompatible because string is not compatible. And the issue which is occurring here is that the inferred type of employee is saying that location is only a string. We can overcome this with using this keyword, which is going to be covered later in the tutorial, as const, which simply tightens or narrows the type of the inference. Now you can see that the location is inferred as London. Finally, one thing I want to touch on with respect to types. Now, we covered objects and arrays, and I want to show one more type possibility with the type alias keyword, which we can't do with interfaces, but it can be quite useful, and that is the tuple type. So the thing about tuples is that we covered already the array type. We said something like array, and that was string. Then we use this syntax and we said, okay, well, this is, let's say in the case of our example, we want to say number, and we want to say that Boris's compensation or salary isn't a single number. He has a base salary, and that's going to be 100,000, but he also gets a bonus, and that's going to be 20,000. Okay, but the thing about arrays is they can be of any length, and they can also mix and match. We'll just say that rather than have the type of number here, we might say variable. And so we don't necessarily know what the bonus is going to be until the end of the year. But now we're being told, well, this is a problem because this array is expecting only elements of type number. So what we might say is, okay, well, let's make this a string. And that's fine. But if we were to grab out the first element, and we're going to call that base, and then we're going to get the bonus amount, or bonus keyword in this case. We're going to say this is a salary. Now we can hover over base, and we can see that this is either going to be a string, a number, or undefined, because TypeScript doesn't know how long this array is necessarily going to be, how many elements are going to be in the array, and it also doesn't know if the element at the 0th index or the first index is a number or it is a string. All it knows is it could be a number or a string. But there is a concept called tuples, and so we're going to show how that works. I'm going to say type, and in here we're going to say salary. And salary is going to be a tuple. It's going to have a base, and that is going to be a number. And it's also going to have a type of bonus, and that's going to be a string. So now what we can do is, rather than say this is an array here, let's say this is a salary, which is this tuple type. And if we hover over base, we can see we get number. If we hover over the bonus type, we can see we get string. And if we were to access another variable, we would be warned to say that this tuple only has a length of 2. So tuples can be quite useful. At the end of the day, when the transpilation takes effect, all of this information is going to be lost, and it's just a simple JavaScript array. But during development, this can be helpful to reason about if you like to use arrays in some cases over objects. We saw that TypeScript allows us to declare the type of an object using the type keyword or interface keyword, or otherwise will infer the type when creating the object and assigning it to a variable. Function signatures work in a similar way, and when we write a function, we will be able to have TypeScript infer the function signature type. So for example, let's say that we've got this function add, and it is a function which takes 2 parameters. We've got a, and that's a number, and we've got b, and that's a number, and then it returns the value of a plus b, and it has a return type of number. Now when we go and we call add, we can see that the function signature is available to us. It's got the a and b, and so if we were to pass in hello, and then we would see that it's complaining because the type of the parameters that we're passing in are not valid. So let's fix that, and we'll put in here. Now it's not a problem. But sometimes what we would like to do instead is declare a function signature and then reuse that function signature. For example, let's say that we have a bunch of arithmetic functions, add, subtract, multiply, and divide, and we want them to all have the same signature. That is to say, they take 2 parameter arguments and they return a number. So we can do that using the type keyword, and we can say that this is my function, and this is just a general signature for the functions that we're going to be writing. It takes a, and a is a number, and b also a number, as we know, and it simply returns a number. Now what we can do, we can actually get rid of all of this information here, or this additional syntax on our add function. And we can say that this const add function is in fact of type my function. So now, even though we haven't explicitly said that a is of type number, we can see that it is picking that up based on the signature. We could copy this and we could say, okay, well, we actually want a subtract, and we're going to rather subtract. And because the parameter arguments and the return type are the same, we don't have to repeat ourselves in this case. We could then also create, say, a couple more, divide and multiply. And so we could say in here that we're dividing and then we are multiplying. And so we can see that by declaring a function signature, this is a quicker and easier way to, in some cases where the signatures are the same, ensure that our code is pretty concise and we don't need to repeat ourselves. Interfaces work in a similar fashion. Let's say that we want to declare an interface function signature. We're going to call it my function, and we are going to simply say that this is a function and this is going to return a number. Now let's go back to our add example. We can say add, and we can say this is my function, and we need to set parameters in here. So we say a is a number, b is a number, and now we can say a, b returns a plus. We can hover over a and we can see that it has a parameter type of number, and b has a parameter type of number as well. So we're able to achieve the same outcome once again by using the interface keyword to declare our function signature, or using the type keyword to declare our function signature, or otherwise we can simply have TypeScript infer the function signature for us. Now I've mentioned that broadly you can use types and interfaces interchangeably. There are a few different cases where we can only use types, and there are other circumstances where interfaces may be useful. What I want to point out here is that we can also extend from types and interfaces, but the syntax, much like in the case of the declaration of the two, or in the case, for example, of function signatures, the syntax differs, but we can still get ultimately the same outcome. So in this case, on the left-hand side, we've got a type of staff member, and on the right-hand side, we've got this interface of staff member. They both contain exactly the same fields, so name, salary, role, and type. You can imagine the type could be either contract or permanent employee, and it has this question mark which indicates it's an optional property. So we can instantiate an object down here. For example, on the left hand side we have Boris. He's earning 100,000 in salary. His role is pilot, and if we include a type, that's okay, and if we don't include a type, that's also okay. So here I can say that Boris is a permanent employee and it's not going to complain. So this is the type syntax on the left, just to be absolutely clear, and on the right hand side we're doing exactly the same thing, but we're doing it with interfaces. Now sometimes we have a base type and we might want to extend upon it. For example, we may have had certain information, but then we've gone and read additional information out of the database, and now our data shape is larger than it was before, but it still contains the fields that the original base type had. So we don't want to have to repeat ourselves and have to repeat out all the fields that existed in staff member. We could say, for example, that we've obtained the ID of the staff member. So what we can do is we can say that we've got the type of staff member, we've got a new type, and it is with ID. And then we can simply provide a new field. So in here I'm going to say ID, and we're going to say that ID in this case is a number. And the way that we extend types is we use the intersection, which is represented with the ampersand. And what that's saying is that we want to essentially join these two together so that we have the original fields of staff member as well as this new ID field, and we want to combine the two together and then provide it down below as the staff member object. So now we will have an ID available. And the way that we do that, we just use the ampersand, then we say staff member. And now if we go and we change this to be staff member with ID, it's now going to tell us that there's a property ID is missing. So this is easy to fix, of course. I'm just going to say ID is 99, and now it's not complaining. But the point is that we don't have to repeat ourselves. We can build upon the original type declaration, and we can use existing types to create new types. And this is how we would combine two types with respect to using the type alias syntax. Now, on the right hand side, we have the same scenario, but we've got an interface of staff member. The same fields and the same exact properties are on the instantiated variable of staff member, but the syntax with respect to extending interfaces is different. So what we do is we declare a new interface, just as we declared a new type on the left hand side. I'm going to declare this. We're going to call this staff member with ID, and now we use the extends keyword, and we can say that this extends staff member. And here we can now include this ID of number. Of course, we need to go and update this, and we're going to say this is staff member with ID, and we're getting exactly the same warning, and that is to say that the property ID is missing in this type down here, which is an interface. That's going to be a word that TypeScript just uses interchangeably with respect to the errors, but here it's telling us that we need the field ID. So I'm going to add this ID, and we'll say it's 888, and now it's not complaining. So the syntax is different for type aliases and for interfaces, but ultimately we are achieving the same outcome. We've seen the different syntax with respect to extending interfaces or extending using the ampersand, which stands for intersection in TypeScript, to use a type and build upon types. But we can actually mix these together. There's no limitation with respect to us saying that this staff member ID here, which is an interface, I'm actually going to change this to be a type alias, and then we of course need to use the equal sign to say it's a type. And now it's not complaining at all. We still have the exact same staff member, and we can see that if we hover over the staff member, we can see it's got the field of ID, and that's a number. So that is acceptable. And in the alternative case, let's say that we wanted to say that we turn this back into an interface. So the staff member is now an interface. We can still do type staff member, and of course we have to remove this. We have to say equals, but we can use the ampersand here to say that this staff member ID, which is a type, wants to extend this interface. That's also totally fine. There is, however, one nuance which I'm going to demonstrate here. Let's say we wanted to have two interfaces above, and we're going to call one interface basic data. And this might be some database fields. So there might be, for example, a version number, and that's going to be a number. And then there's going to be a date, and that is a date. And so obviously we can't use the equals if we're using an interface, but it ultimately doesn't matter. But the good thing about types is we can come in here and we can say that this extends staff member and it also extends basic data. Now when we go down below, the diagnostics is telling us that we are missing the types from basic data, version, and date. So in this case, we've used the type and we've actually built upon two existing types, or we've extended from two existing types. In the case of interfaces, however, here, if we wanted to include basic data and also staff member and extend from both of them, this isn't available. So if I were to use this syntax here, then we are going to see that this is indeed not correct syntax in TypeScript. We can't extend from two declarations that we've got above, and that is a limitation of interfaces, whereas with types we are able to achieve that. We saw earlier with interfaces that we can extend interfaces, and then we saw the same syntax when it came to type aliases and how we could join type aliases using the ampersand. Just going to build on that a little bit because it's important to understand how unions and intersections work. We're going to be using them a lot within this course, and so I'm just doing a quick recap here of how they will work. When we think about the union, of course, we could declare this here with something like transport, and we could say that transport is a union of yacht and also aeroplane. This is going to grab all of the common characteristics between each of these types. And if we were to use the ampersand, this would grab all of the fields which are in either aeroplane or yacht. Now, this hopefully makes sense and is not that complicated. I just want to introduce you to the fact that this will be something that you'll see in many code bases where it's provided within the parameter type, or in fact even the return type. And just to show you that same syntax, whether we're talking about a union or we're talking about the ampersand, and what we would refer to with the ampersand is an intersection, is going to be the same no matter where you encounter it. So you can still use it here. For example, I'm using it in the function parameters, and we're just going to quickly look at the type of the transport object that's being provided to this transporter function. So let's start with the union. As we mentioned, if we have a union of two types or interfaces, then simply we can see that we've got all of the common fields that exist in both of these types. So we've got make, name, and price, and you'll see that that exists in both yacht and aeroplane. And then if we think about using the ampersand, which is an intersection, and you can think of that in a way that you would think about this is a join between these two. So we're combining all of the fields of yacht and aeroplane. Now when we come in to have a look at our transport, we can see that we have cabins, which exist, for example, on the yacht, but don't exist on the aeroplane. And we have seats, which exist on the aeroplane, and they don't exist on the yacht. So this is just a quick recap of how unions and intersections work. You're going to be seeing a lot of them, so I hope that that clarifies. I'm going to continue from this point in this section using the type keyword in TypeScript to declare types, although I will switch between the two so that you get comfortable. In this next section, we're going to consider enums. And enums are unique to TypeScript. They're not available in JavaScript. And they're also unique along with classes, which are unique in the same way, in that they represent a value and a type. I mentioned before about type space and value space. We can see here, for example, that if we remove this, just to make things particularly clear, we have a type staff, and then we have the value of staff. Ordinarily, we will differentiate between the two being types in Pascal case and values in Camel case. But enums are actually a value and a type, which means that they can be used as a type within TypeScript, but when transpiled, they actually get converted into valid JavaScript that is available at runtime. In this case, we have a staff member who is in the role of a pilot. But using a string here is not very good practice because we could pass in any type of string. For example, we might name pilot incorrectly. Really what we want is a constrained set of roles that exist within our airline company in this case. So what we can do is we can declare an enum and we can call this roles. And in roles, we can say something like we've got pilots, we have ground staff, and we've got flight attendants in this example. So rather than the staff object or type declaration being given a role type of string, we can now simply say that this is type of roles. So now when we go and create this value, declare this constant of staff, we are being given a diagnostics warning saying that string is not assignable to the type of roles because pilot with a lowercase p doesn't exist in this set of constrained values. In fact, if we hover over any of these, like pilot, we'll see that it's been assigned a value of 0, ground staff has been assigned a value of 1, and flight attendants have been assigned a value of 2. Or rather, we'll call that flight attendant. So now what we can do is we can actually just pass in the roles.pilot, and we're not getting any complaints. There are a few things that we need to be careful with enums though. For example, right now we've only got 3 roles, but realistically in an airline company, we're going to have any number of roles. We might need to add roles in the future. We might have to add, for example, security. The problem is that pilot is still assigned a value of 0, but ground staff, which was previously 1, is now 2. This can cause serious issues with your production app because now when all of this is saved to the database, you are going to be receiving different values depending on the roles. And so someone who was previously saved into the database under the value of 1 is now saved as 2, and you've mixed up security, ground staff, and also flight attendants. This is because enums in TypeScript automatically increment. If we provided pilot with a value of 10, then we'll find that security is a value of 11. It's just automatically incrementing. One way around this would be to include in your team's documentation to always include any new enum properties after all of the existing down the bottom. So we could have actually included security down here, and that would have solved our issue. But as you can imagine, in code reviews and the fact that TypeScript is not giving us any warnings here, this could still slip through and cause issues in our application. So it's not ideal. But putting something at the end is not always going to fix the issue, and as I mentioned, it may not get picked up. What I prefer to do with enums is just to repeat in what is called a string enum. So here, pilot is equal to pilot, ground staff is equal to ground staff, flight attendant is equal to flight attendant, and security is equal to security. Now we don't have any confusion and the order is irrelevant. So we could add in security back where we did before, and if we hover over security, there won't be any issues because it's been assigned to a unique string literal, and therefore we can't have this versioning auto incrementing issue with respect to enums. Enums, generally speaking, are a better way to handle the constrained set of values, and they're particularly relevant in the case like an example here where we have staff that could be of a specific role. You could have managers, analysts, different levels, or you can imagine in the military where you have a private, you have a sergeant, you have a lieutenant, whatever it may be. And so we know that we've got a constrained set of values and we want to make them consistent. So when we save them into persistent storage in a database and we grab them out again, we know that we're always dealing with exactly the same shape of data. Now I mentioned that enums and classes are slightly different in their behavior. On the right hand side, we have the transpiled version of the code on the left hand side. And as you can see, we've got a lot of the code from the enums has been transpiled into this function here, which has created this object with these keys and values. And so this isn't purely a type, but rather a value that will exist in the runtime environment. And that is something unique to enums and also classes with respect to TypeScript. We see that the enum starts with this capitalization, and that is an important distinction in terms of standard practices within TypeScript, that you would capitalize your class names and your enums and be aware that both of those represent not only a value space, but also a type space. Types, on the other hand, they're capitalized, but they have no associated value space. And you can see over here that this const staff has made its way into the transpiled code, but there is no reference. We can't see any reference to this type staff, which has been stripped out, as I mentioned before, in the transpilation explanation. While enums have a time and a place, they do have limitations, as I've outlined. And they also require, if you are publishing your code as a third-party repository or putting it on npm, for example, that the consumer imports enums. Because even if here, for example, I had passed in pilot as a string, that would not be accepted by TypeScript. So it can be a little bit annoying sometimes if you are using another code base or you've imported a library and you need to then import the enums associated. One alternative approach is simply to use a type union. So what we could do instead of having that enum, we could say that we've got this type and we are going to call that roles. And in here we have pilot and we have ground stuff. While not as restrictive as an enum, it is much more narrow than a string, which was the original implementation, if you recall. So now when we go to create our staff member here, then we can simply pass in the string and say pilot, and we get no complaints. We still get the benefit of, for example, a typo or an incorrect match, but we no longer have to import that enum in order to use it correctly. You will find the best point to use type unions and enums in different situations. It's just important to understand how they work. Now, I'm going to change things a little bit here, and we're going to think about this staff in an airline being either contractors or permanent staff. What we might say is that contractors wouldn't have an hourly rate, and what we might say is that contractors would have an hourly rate rather than a set salary. They would still have a name and they would still have a role, but maybe they would have a type of employment. So we want to deviate now from the single type of staff member. What we can do in that case is we could simply call the general top line as staff. All staff have a name and they have roles, but in this case, we want to have an interface which is a contractor, and that extends staff, but they also have an hourly rate. So now we're going to say that this is an employee, and we also want to point out that we've removed salary from the staff top line declaration, and therefore we need to have a new interface or type. We can use whichever, I'm just changing between them, which is going to extend staff, but it's also going to have salary. And so now we can see, okay, we've got this employee, and this is going to be employee, and they've got a salary. And then down here, we're going to say this is a contractor, and they are of type contractor. And they are going to, let's say this is Daisy. Daisy doesn't get a salary, she gets an hourly rate. And then her role is in fact as ground staff. So now we've got these two distinct types of staff. We've got employees and we've got contractors. We can put one more thing in here as well, because we can imagine that, well, employees, you could have an employee who's a pilot, you could have a contractor who's a pilot. That's totally fine. But we want to be able to differentiate between these two so that when we save these into the database, we also save their employment type. So if we come up here, we can include an employment type, and we can say that is an employment type. What I'm going to do is I'm going to show you one last alternative on top of the enums and then type unions, and that is that we can have a const object, and this will make sense. So if we had an object, let's call it employment types, and we can say that these are either going to be contractors or they are going to be permanent staff. Now, if we hover over employment type, we're going to be told that contractor and permanent are in fact only strings. But what we can do is we can use this keyword as const. The as const does is it narrows down the types of the properties and makes them read only in this employment type. So now when we hover over employment types, we'll see that there are two properties, contract and permanent, and they each match with their respective value, which is not a string, but rather a string literal, contract, or permanent. So we can now use this and say this is keyof type of employment types. So here we're using a TypeScript keyword type of, and this differs from the JavaScript type of. And this is saying that this is a key of this type of. Let's take a closer look at this. Let's say we have employee type, and it is equal to the type of employment types. Now that's going to give us the type declaration for employment types. But what we're really concerned with here is that it could be the key of that we're concerned with. So for example, we would say that key of, and if we hover over employment type here, is either going to be contract or permanent. So this is the same outcome as implementing this type union, although it does have more of the syntax that you would imagine with enum. These are different approaches, and I'm just showing you how we can approach them. What I'm going to do for the time being, because I personally find it acceptable, is I'm going to just change this to an enum. Now we have our employment types, and we need to go down to each of our staff and indicate what kind of employment types these are. So for example, let's say that Boris is going to be a permanent employee, right? So let's say that employment type is employment types permanent. And then in the case of this contractor Daisy, employment type is going to be employment types dot contract. Now we've got these two different types of staff members, and they have different entitlements. For example, the contractor, we can imagine, is not entitled to annual leave, whereas an employee is entitled to annual leave, or a permanent employee is entitled to annual leave. So what I'm going to do is I'm going to create a function which is going to make a determination as to whether this individual staff member is entitled to annual leave or not. So let's create our function, and we're going to say is entitled to annual leave. And it receives a staff member, and that staff member can be of type employee, but it can also be of the type contractor. Now in here, we just need to check to see if this is going to be a employment type of contract or an employment type of permanent. So let's see how that works. So if the employment type is contract, then we would return false. Otherwise, we're going to say it's true. Now, it may be the case, in fact, that the employee and the contractor have different data beyond that. They may, at the moment, they all share the same fields except for the hourly rate and the salary. So we want to calculate the employee or contractor salary. If we say in here, calculate paycheck, and we're once again going to pass in a staff, and that's going to be an employee or it's going to be a contractor. We need to determine how much the paycheck should be for either the contractor or the employee. The thing is, we have an hourly rate in the case of the contractor, and we have only got a salary in the case of the employee. In order to determine the paycheck, and let's say this is the monthly paycheck, we would need a little bit more information in the case of the contractor than we would in the case of the permanent employee. The reason being that we can simply divide the salary by 12 in the case of the permanent employee, but in the contractor's case, we need to know how many hours they worked in that month in order to determine how much their paycheck should be. So what we could do is we could say, all right, let's add in here a hours worked, and that's going to be, say in this case, we're going to say that this contractor worked 200 hours for the month. And of course, we need to add that onto the contractor's declaration. So we can say hours worked. Now, one way to do this, we could say that at the moment, we're going to need to check if this staff member is an employee or a contractor. I'll show you how that works and how we have come into somewhat of an issue with the design structure that we've used to approach this. Let's say, for example, we want to calculate the permanent employee's salary for the month. Should be pretty easy, right? We simply get the salary and then we return that salary divided by 12 months of the year. So let's try that and see what happens. So we say if the staff.employment type equals employment types dot permanent, then let's get their salary, and we will notice that there is no salary on the staff. Why is that? Well, that's because TypeScript doesn't know yet if it's dealing specifically with an employee or it's dealing with a contractor. It should, however, know. And there are a few ways to approach. The easiest would be to say, okay, well, this employment types, we're not going to declare it in the parent type that we are extending from. Rather, let's do away with that. And in the case of the employee, we're going to include this employment type, and it's going to be employment types.permanent. In the case of the contractor, we're going to have the same approach. So we're going to say employment type, and that's going to be employment types.contract. Now, what we can do is we can come back into our calculate monthly paycheck, and we can see that by doing this check, if staff.employment type is permanent employment type, then actually we are aware that we have exactly in this moment access to a permanent staff member. So if we go to this employment type, then we can see here that it's of the permanent employment type. Otherwise, so let's just finish our work here. So we can just say, what's the salary? The salary is staff salary, and then we can simply return the salary divided by 12 months. That's fine. But now let's say we need to check in the case of the staff.employment type is equal to employment types.contract. Because if they're a contractor, they're going to have an hourly rate, and they're also going to have an hours worked. Now what we can do is simply return hourly rate times hours worked. We can see here that that's going to then return. Now we have one problem here, which is that we haven't actually declared a return type in this function, but we really don't want to hear or have a situation where we don't return anything. However, we've got an if or an else if, and there's no else here. So there is a case where the employment types have not been correctly set that we won't be returning a number. So if I include the return type of number here, we can see that it's giving us a warning and says that it doesn't include the type undefined. By default, this function is going to be returning undefined. What we can do in this case is, though, we should always have an employment type on any staff member, whether they're a contractor or permanent staff. And so we can throw an error, and we can simply say something like staff employment type not set. Now we're not getting any errors, and we have successfully differentiated between permanent and contract staff for the purpose of our calculation of the monthly paycheck. Sometimes, though, we don't have the ability to go back and amend types. We might be importing these types from a third-party library, and in this case, the design didn't allow us to set the particular type on the sub-employee or contractor declaration, but rather it was set at the staff level as we originally had. So if we remove the types here, and we simply add back in the employment type, now we have got to make a few adjustments to our program because we don't have the benefit of having narrowed down our type based on the employment types being permanent or contract. You can see in here that even though we know that we're dealing with an employment type at the moment, we don't necessarily know that it has the properties that we want because of the level that these properties have been set at. In this structure, which is suboptimal, the employee here could have a permanent or contract type, and a contractor could also have a permanent employee type. So this wouldn't be a good design. And sometimes you come across designs like this. So what would we do in this kind of case? One approach is we can say, okay, I know that I'm safely within dealing right now with a permanent staff member within this if statement. So what I can do is I can say if salary in staff, and we can then grab this, place it in here, and now we've been able to check, and we can hover over the salary and we see that it's a number. So we have determined that this salary property is in this object. So we've been able to narrow this staff member down, and therefore we can safely do our calculation. The same thing would occur here. We would need to say that if hourly rate in staff, we grab this and we can see that it is working. Now you might say, well, hang on a second, we've checked hourly rate, but we're also grabbing off the hours worked. And that's true. But the thing is that TypeScript is smart enough to determine that if the object that we're dealing with has the hourly rate, we've therefore narrowed it down because recall we've passed in this union of employee or contractor. If the hourly rate property exists here, it must therefore be a contractor and therefore also have the hours worked property. If this was optional, which we can do up here in contractors, and we can say hours work is optional, we'll see that we have a warning from TypeScript saying that this is possibly undefined, and we can do away with this in two ways. One of them, which is bad practice, is to assert that this is non-null. We could put an exclamation mark at the end, and that's to tell TypeScript, I know better than you, and I'm telling you that this is not nullish, therefore I know that it is type, this is saying it's of type number. So by putting in the bang or the exclamation mark at the end, we are narrowing it down to say that it is not of type undefined, it's only of type number. And we can see that to say hours worked is hours worked. If we hover over this, we will see that it's of type number because of that. But that is unsafe ultimately, because it's possible that if the original designer of these types had included this as an optional parameter, then we would need to take that into account in our code. And that is really what the benefit of TypeScript is trying to get us to consider all of the different edge cases, encourage us to write code that won't result in runtime errors. So it's telling us that hours worked is possibly undefined. So we can say and hours worked. So we can say if hourly rate is in staff and the staff object has these hours worked, then go ahead and calculate the paycheck for the month. So we saw that with asconst, TypeScript's inference system was inferring a tighter definition, a narrower definition with the asconst keyword operator. And now I want to introduce satisfies. And satisfies is a really interesting operator. And I'm going to show how it works, and you're going to see that this could be super useful in your code. So what we're going to do, we're just going to say that we've got a type, and this type could be anything. We're going to say, for example, that we've got a config. Let's just say it might be a database configuration, for example. And in here, we might have a port, and that could be a string, or it could be a number. And then we have the URL, and that's a string. And we have the password, that is a string. And then finally, we might have the user, and that is a string. So we're going to instantiate this. We'll say we've got our config, and this is the object that we're going to be passing into the database. You can imagine this might be environment variables or something like that. And the port we're going to say is 888. And the URL is going to be this URL here. And then we've got the password, a very, very tough password. And then finally the user, we're going to say that this is going to be Boris again. So here we have this config, and I'm just going to export this so that it stops giving us that error. And we're going to say that config belongs to config, right? We've seen this already when we looked at excess property checking and applying the types at the time of instantiation without inference, and that's fine. But let's say now we go to port, and port has to be a number, and we know that it's already a number. So let's say we go to config.port and we hover over this, and it tells us, okay, this is a string or it's a number. But that's really annoying, because actually we know for a fact that we've hard coded that in here. We know that that is a number, and so we can actually once again tighten our type definition and say that this satisfies config. So we can now remove the config from here, and what this means is that we've got this type definition up here. That's great. It's good that we've documented it, and it perhaps had to accommodate two different types in here under port for whatever reason. But rather than declare that this is the type of config, we are going to say that this satisfies the type of config, but we're going to retain the type inference that TypeScript is providing us. So now if we hover over port, we can see that port is a number. Why? Because it's been inferred from what we've provided and not simply declared as the type from the original type declaration as we had before. This can be quite useful in circumstances where you're using some standard type and actually it should be inferring more than what it is. You still want to use the available types, but you don't want to lose the inference that you're getting from TypeScript. The satisfied keyword is super useful. In this next section, I'm going to introduce some of the keywords from TypeScript and give you an understanding of how these can be helpful when declaring types or creating types from other types. There's three here that I'm going to work with: typeof, keyof, and also the as keyword, which for various reasons we will look to avoid. The first one is typeof. So let's imagine that we have an object, and this object is simply any old object. It just includes a name and it includes a location. We can see here that this object has an inferred type, but there's no actual a type associated with it. We can't say use this in any functions. For example, if we wanted to print the name out in a function, we could say, and we would say that this is an object with a name. We can't actually do this. We can't use object above as a type. What we can do instead, though, we can say that this is type of object. Object's probably a poor word in this case, so let's just rename it. So now, even though we haven't declared a type, we are able to grab the type of this example object. And this can be obviously very useful when creating objects and then not having to then go away and type everything out so that we can use it elsewhere. So this typeof is one of the keywords in TypeScript, which I tend to use quite a lot. The next one is where we want to get the keys from something. You might have a type and it might be, say, a car. And the car may have a brand, and that might be a string. It may have a year, and that may be a number, and it might be a type, and that may be a string as well if it's a sedan, a wagon, whatever it may be. So we've got this type car, and it's got brand, year, and type. And we might want to map through it for whatever reason. So we may want to create an array that includes all of the keys for cars. And the way that we would do that, we would say call these attributes, and we're going to say that this is going to be a key of car like this, and it's going to be an array. So now, for example, we can say that this has type, it has a brand, and it has a year. If we were to put in a value here, for example, drivetrain, maybe, we can see that that isn't actually an appropriate value because this is not a key of the above car declaration. Where this becomes particularly useful is in the case of using keyof and typeof combined. So let's imagine that we get rid of car for a moment and we go back to our example object. Our example object is just a person by the looks of it. Their name's Harry, they're based in London. And all we want to do is we want to get the keys of this example object. So we can actually combine this and say it's a key of type of, and then example object. Now it's going to throw us an error on all of these, but for example, we can include name and we can include location. And now, without having used the type keyword and having to write out our own types or interfaces, we've successfully been able to build our own types and build in this array and have all of the type syntax based off of the value, rather the type of, and then the key of this example object. Finally, we're going to discuss the as keyword. As means that we are, in most cases of its usage, asserting the value. That's to say that we are telling TypeScript that we have more information than what TypeScript has. We might do something like this. Let's say that we have a type and it is an array, and it's an array of names. And we're going to say that this is simply going to be a string array. Pretty simple. And I'm going to remove this other example just so we can focus on this as key. But now I've got this type array of names, and it's just literally an array of strings. And I go and I declare const names. And of course, this is going to work if I put in here names, right? And I can assign this and say array of names. Totally fine. But what happens where we deviate from what we've declared above? We can use the as keyword and say this is an array of names, and we could start to put in things like the number 1, for example. We can say that this is null. And of course, if we were to delete that as keyword, we're going to get warnings from TypeScript to say that number is not assignable to type string. If you want to include that, you can use a type union that we touched on earlier. But by including this array of names as array of names, we are telling TypeScript that we know better than TypeScript. And in fact, we know that this is an array of names, even though TypeScript has no reason to believe that. And in almost all cases, you should avoid this type assertion. You are better off always using this syntax on the left-hand side, where you use a colon, and then you say the array of names, and then you provide it with the array, and you don't use this as type syntax. There is the rare occasion that this might be appropriate. You can imagine that if you're reading from a NoSQL database that in fact you have good structure on, in the case of Mongoose, for example, some of the versions that I've worked with, they don't have good integration with TypeScript. So you might read out of the database, you know exactly the shape of the data if it's successful, but Mongoose might not be providing that to you, or the third-party library might not be providing to you, or the API. And so in that case, once you've done your validation checks to check that you have received some data back, then it may be appropriate to use the as keyword. But within your own program, you should almost never use this. And you should always stick to the syntax on the left or TypeScript inference, and not override the TypeScript with the as assertion. This next example covers a fictitious hypothetical scenario where we are working with another team's module or a third-party package, and we don't have full control over the imports of the types. As a general rule, it's better to export all of your types because there are ways to extract them anyway. In this case, however, we have a staff database which is building upon the employee and contractor types that we were working out earlier, and it has exported the enum roles and the enum employment types, but whoever is the author of this package has forgotten to export the employee and contractor type. Let's see if that's going to be an issue. Just quickly taking a look here though, we've got 2 employees. Boris, he's a permanent employee, and we've got Daisy, who's a contractor. Our database, all it does is it simply returns this list of employees that we have in our employee. Don't be intimidated by this syntax. We're going to get into classes later. The idea is just to create this scenario so you can imagine in the real world, when you're dealing with another package, the kind of hurdles that you may need to overcome. So the first thing that we're going to do is we're just going to see what this database has available for us. So if we go to DB, we can see it's got a staff field, and if we hover on that, we can see that this field on staff that the TypeScript language server is telling us, giving this great support, has an array, and that includes employees and contractors that we were working on earlier. So the first thing I'm going to say is declare this variable, and we're going to call it list of staff. In this scenario, we want to calculate bonuses. So we're going to calculate the bonuses. The idea is that permanent employees will get a 50% bonus on their salary, and contractors, they're not entitled to any bonus. And you can imagine that this is quite standard in industry. So us as a company, we don't need to give our contractors any additional bonus. So what do we actually want? We don't need all of the information associated with our employees and contractors. All we need is the ID and name of the contractors, and if they have a bonus, to see their associated bonus. What we're going to do then is we're going to declare a new type of what we're looking for. So that type specifically is going to be name, ID, and bonus amount. And that's simply going to look like this. We're going to have a name, it's string. We are going to have an ID, that's a number, and we are going to have a bonus amount, but it's optional. And if it is available, then it's going to be a number. So we need a list of these, and therefore we're going to create a list, and we're going to pass through our list of staff, and we're going to recreate a new list, which is going to be our name, ID, and bonus amount. Finally, we're going to console log that out. So const say that that is a list, so names, IDs, and bonuses, and that's going to be equal to the name, ID, and bonuses. We're going to build on this in a moment, but just for the sake of clarity, we're going to console log this out. So we've got this list of staff, and we're going to use this list of staff, and we're going to map through each of the staff members, calculate their bonus if they're entitled to a bonus, and then return their name, ID, and their bonus. So we say list of staff.map, iterating through the list of staff, and then for each staff member in the list, we're going to perform some actions. So we're going to say this is a staff member, and in here we're then simply going to form our logic. Now we're getting a few warnings, but that's okay because we haven't completed everything so far. The first thing that is popping up is it's saying that type void is not assignable to the name, ID, and bonus amount. And that's okay because we haven't actually returned anything in our function here. And then we're getting another warning which says that staff member isn't read. That makes sense because we haven't actually dealt with it yet. One thing to note with higher order functions though is that we can pass in the type that we're going to be dealing with. In this case of map, what we're going to be doing is we're actually going to be returning on each of these elements in the array a name, ID, and bonus amount type here. And this tightens everything up so it knows what to expect. This means that now if we delete that declaration there, we can see that our const names, IDs, and bonuses is still inferring the correct type because we have told map exactly what we want. Just as a side note, I always think that it's better to put return types on functions, although it's ultimately a matter of personal taste and opinion. The reason that I argue that they're important is because I can quickly jump into any code base, see a function, and reason quickly about what that function returns. I don't need any documentation because TypeScript is self-documenting, and I don't need to look through that function or even hover over it to determine what the return type is. I'll let you make a decision on what you think is the best approach. Now we've got this staff member and we've only got to do two things. We need to make a determination as to whether the staff member is a permanent employee or they're a contractor. If they're a permanent employee, we're going to calculate their bonus, which is going to be 50% of their salary. And if they're contractors, they get no entitlement to their bonus. So we can imagine it's really, if they're permanent staff, they get a bonus. Everyone else, which includes the contractors, doesn't get a bonus. In order to do this, I'm going to introduce a type guard. So we're going to call this function that we're going to use as our type guard is permanent employee. It takes a staff member, and this can be either an employee or it can be a contractor. The problem that we've got in this situation though is that the library that we're using doesn't actually export the employee. As you can see here, it's got the enum, but it doesn't have anything else. These autocomplete items are simply text. So we need to extract these somehow so that we can give the function that we're working on here the correct type union. The way that we can do this is we're going to recreate these. We're not going to rewrite them, but we're going to use an extract TypeScript utility, and this is one of the utilities which I'm going to cover in this course amongst others, that allows us to grab a nested type. So let's say we've got employees or contractors, and we're going to say employee or contractor. We know up here that we've got this list of staff, and I'm going to introduce this keyword which is typeof, and typeof has a different meaning in the type space than it does in the value space. If we say typeof and we say list of staff, this will actually give us the type declaration that corresponds to this value here. So list of staff, if we hover over it, is a const, and it's an array of employees or contractors. If we hover over our employee or contractor, we can see we've extracted a type here, and it's called type employee or contractor, and it's an array of employees or contractors. But we actually don't need the array type. We can drop this array because we're only interested in elements that are specifically part of this array rather than the array itself. And we can do that by using number. So by implementing number there, it's now getting out the element, the type definition of any element at any position in that array. So now we have an employee or contractor. So if we come down to our is permanent employee type guard, we can say this is an employee or contractor that we're passing in. So far, so good. But with this approach that I'm taking, I still need to narrow it down even more. And the way that I'm going to do that, I'm going to say type employee is equal to, and I'm going to say extract, and that's the extract TypeScript utility. I'm going to say it's an employee or contractor, and get any type, which, if you recall, employees have a salary field, whereas contractors don't. So we can use salary, and that's type number. And now, if we hover over employee, we will see that we have extracted out that specific type of employee, and we've got all of the associated information on it. So while in the case that you're coding it yourself, you won't need to do this, you can simply import it. In some cases, you need to work with third-party TypeScript libraries, and you may need to massage these types and extract them out in the way that you need. So back down to our type guard, and here our function is called isPermanentEmployee. What we're going to say that if this returns true, staff member is the type of employee. So once again, just walking through this function is called isPermanentEmployee. It takes a staff member. That staff member can be an employee or a contractor. It checks whether it's an employee or a contractor. And if it's an employee, it returns true and it permanent employee. Otherwise, it returns false. So we can determine that by saying if staff member dot employment type is equal to employment types dot permanent, we can return true. Otherwise, we can return false. Finally, we're in a position where we can actually use this type guard. So let's go back to our original map function. And here we're going to say if is permanent employee, we're going to pass in this staff member here. Then we can do some operations here because we know now that our staff member, for example, we can grab off the staff member, we can grab the salary, and we can also grab the name and the ID. We can say the bonus is equal to the salary, and we set up here that the permanent employees were entitled to a 50% bonus on salary. And now we can return the name, ID, and bonus. We're still getting one warning, which says that not all code paths return a value. And that's understandable because we haven't actually returned anything. So we've only returned it if the employee or staff member is a permanent employee, then we're returning the calculation. But if they're not, we still need to. So here we can once again grab the name and the ID and recall that these individuals who are contractors or not permanent employees are not entitled to a bonus. And we can simply return the name and the ID. So this is how we've used the type guard with the TypeScript is syntax, and we have extracted out types where required because in this scenario, the third-party library that we're using didn't make them available to us. Now let's get a sense check on this and test our code quickly. We can do that by using tsnode, which allows us to run TypeScript files, and then I'm simply going to pass the name of this file, which is this one, and we can see that our program has provided us a list or an array. We've got 2 employees in here. We've got Boris, he's got an ID of 7 and he receives a bonus of 50,000. And then we've got Daisy. Daisy has an ID of 6 and it looks like she's not getting a bonus, which indicates that she is a contractor. And we can quickly go back and we can just for good measure verify that. So here we've got Boris. Boris has an ID of 7. He's got a salary of 100,000, so 50% bonus is 50,000. And then Daisy is indeed a contractor, and so she's not entitled to a bonus. One of the great things about JavaScript is that you can adapt it to either a functional programming paradigm or an object-oriented approach. Both are totally fine, and it's a matter of personal taste. But in this section, I'm going to focus on classes and the benefits that TypeScript has to offer with respect to object-oriented programming and the additional keywords and syntax that TypeScript introduces to tighten up our code. In front of you, you're going to see this vehicle class. The vehicle class is a very simple class. It has a constructor and it has 3 properties: make, type, and owner. And so we pass into the constructor the make, the type, and the owner. It sets these, and then we have a number of getter and setter functions. So for example, we can get the vehicle type, we can get the vehicle make, we can get the vehicle owner, and we can set a new owner if we sell the vehicle. Now immediately you're going to see there is a bunch of new syntax that's been introduced from type. The first thing that comes to mind is that this vehicle class has 3 properties, which in this case, make is a string, type is the vehicle type enum above, which we've already explored enums, and then finally owner is a string. Now, if we don't include these, then TypeScript is going to throw an error. So it's quite restrictive that we need to think about the shape of our data before we go and start applying or adding properties to our class. We can be even more restrictive with this. For example, we might want to make this private and read-only. These are 2 keywords which TypeScript introduces that allow us to be even more restrictive, but it is important to note that the private and read-only keywords, as we explored before when we transpiled our TypeScript code into JavaScript, this is going to be lost. So this isn't actually going to prevent anyone from at runtime accessing these properties or treating them as though they're not read-only. It's just a development tool at the end of the day, and it's important to understand that. On that note, if you're familiar with modern JavaScript, you will know that you can make properties private by prefixing them with the hash. So if you were to do that, then you will need to go through here and update all of these. And on that note, it is important to consider that this now makes the property private. And if we hover over this vehicle, see, we shouldn't be able to access it down here where I've instantiated it. So let's say vehicle, and we can see that we have the type and we have the owner, but we don't have the make because the make is private. So this at the end of the day though is JavaScript syntax. So it's native to JavaScript, and the rule generally speaking is that where it's possible to achieve the same outcome with JavaScript, it is better to use JavaScript itself. I've made all of these properties private, but we can still prefix them with read-only. So that makes it even stricter, so that even within the context of our class, we can only read-only. So once we've instantiated this class with a constructor, and then we have added all of these properties to the class. So for example, make, type, and owner. In the case of make, let's say if we wanted to come down here and create a new public setter and would say the new make is a string, and then what we try to do is we say this.make equals new make, we're going to see that this is actually not acceptable because this is a read-only property. The read-only keyword is not specific to classes, but this is an example of its use. And typically we want to use read-only so that we restrict any mutation of variables. Next, we've got the vehicle type, and we can't change the type. So once a vehicle has been made, it's going for the most part be the same type. Finally though, we've got the owner. So in this case, although this is a private variable, we are going to set it to not be read-only. That is to say that we can mutate this property. Down here, I've got this public set new owner, and all that does is it allows us to set a new owner on the vehicle. I'm going to show you that the syntax is slightly different to what you would expect with JavaScript, because let's say we have the vehicle and we want to get something off the vehicle. Let's say we want the vehicle type. Then we can access it like so. We can hover over this, and this is telling us that we've assigned a vehicle type. There's a similar approach with respect to setters. So if we wanted to set the vehicle owner, let's say I've sold this vehicle and we want to transfer the ownership into someone else's name. So we can say vehicle.newOwner, and in here we might say we've sold it to Boris. It's not actually callable like that. In fact, the way that we would do this is we would say that the new owner is Boris. Now, if we had not had this setter, we would not be able to access that private variable in here. And let's say we turn this back to private using the TypeScript syntax, we still wouldn't be able to access it. So if we went now and we said vehicle, we can see that there is no owner field, and therefore without this setup we wouldn't be able to mutate that variable. All of these are optional, so at the moment I've set these to public and also private, so we're aware that private is available within the class, so we could use this within the class as we are down here, and we are returning this .owner. We can access all of these private variables within the context of that class. However, if we wanted to inherit from a vehicle class, say in this case, we would still perhaps want to allow the subclass to be able to use these methods, but perhaps not allow anyone to use. The way that we could achieve that is we could say that car extends vehicle, and then in here, if we were to set all of these to protected, we will see that now outside of the context of our class, we can't actually do that. So let's say rather I instantiate this car, and then within the context of the car, we might say that we want to be able to change the owner. And so we're going to create a setter in here, and what that does, so we say this is public. Now what we can do is we can say this dot new owner equals new owner, and see how, because we're a subclass of vehicle and because this is set to protected, we can access all of the protected getters and setters within our subclass, but we can't access them here. So for example, if I went to car, all I've got access to is car owner, and I can set that to be Boris again. Boris is upset because I haven't transferred the vehicle into his name yet. But by doing this, we have restricted access to the class, and only the subclass can access. But if we have a look in our public setter function here, if we say this, we can see we have access to all of the getters and setters that are available in the parent class. So those three are particularly important. The private keyword, which, as I mentioned, has been superseded really by the hash indicating the JavaScript private property on a class, and then the protected keyword, which indicates that this is protected and therefore only available within subclasses that inherit directly from this class, and then finally public, which means that we can access this from anywhere. By default, it will be public. So if you don't include a keyword, TypeScript is not going to stop any other developers, yourself, whoever's using this code, from accessing that setter. We've also seen and gone through all of the getters. So you see the get keyword and the set keyword, and then on top of that, also these return types, which, just like we've looked at earlier with functions, you have return types on all of the methods here. You can also chain methods. So if you wanted to, you could say have a custom method, and you might say change the car owner, and it's going to be a new owner, and it's going to return this. And all it does is just says this dot new owner, and then this will allow you to chain, of course. So for example, if we wanted to, we can, rather than use this syntax that we were earlier with the setter, we can say use our new method, change car owner. We can put Boris's name in there, and now we can go and still use other methods on the class. So that's how you would achieve chaining on a class. There are a few more keywords that I want to cover with respect to these classes, and one of those is the static keyword. So here, if we wanted to, we could have a static method, and we would say that this is a public static method. And a public static method is a method which doesn't require the class to be instantiated. So for example, we could just console log, we could log the day. It has nothing to do with vehicles, but you can just imagine that this car class can be accessed, and even before instantiation, you can access this static method. So for example, we might say car dot and then log the day, and that's valid. And often I would use something like this if I wanted to validate the inputs before passing it to the constructor. So let's say instead of doing something useless like just logging the day, instead we say we want to instantiate or init, and in here I'm going to simply return this. What I'm going to do is this is going to take the exact same inputs as the original function constructor. And here, one thing that particularly with TypeScript that I like to do is, instead of passing in these parameter arguments in the fashion that we have been doing here, it is generally better to create a params type. So we'll just say type car init params, And in here, we're going to say instead, we're going to say the make is a string, the type is a vehicle type, and the owner is a string. Now, when we use destructuring in here, so we could say something like car init params, and in here we could include make, type, and owner. And now we don't have to worry about the order of our arguments, because one of the pet peeves with respect to any of these languages, even if we had owner and make next to each other, you could accidentally pass one parameter in the wrong order, for example, owner before make or whatever it may be, and TypeScript won't give you any warnings because, of course, they're both of the type string. But if they're both of the type string, but you put them into an object that you can pass into the constructor and grab them out through this destructuring, then you don't have to worry about the order. You're going to be referencing it by the property field name. So that is typically something that I tend to do. So coming back down to our example of our init and how validation can be good. Sometimes when we're dealing with input from users or some external API, we don't necessarily know or have a guarantee of the fields or the shape of that data. So what I'm going to do here is I'm going to say that this is going to be the init params, and this is going to be this vehicle, I think we call it car init params. What we can do is we can perform some validation, and then once we're done, what we can do is we can return a new car with these init params. Just one thing to fix up is that we are not actually returning this because we haven't instantiated class yet. And going back to what I was saying earlier about enums and classes being capitalized in Pascal case and being values and types, we can see that here. So here, this public static method that I'm using, I'm not going to be passing we're going to instantiate our class in a slightly different way because we're assuming that we're getting our inputs from somewhere else and we're passing them into this init method. And so it's going to look something more like this. And in here, we're going to pass in this object. This object, recalled if we go to the top, is going to be looking for the make, the owner, and the type. So we can say the make is BMW, the owner is myself, and let's say I actually, for a change, would like a type of tank. But you might say, well, you're actually not doing anything. All you're doing is passing in this to this static method and avoiding the use of the new keyword, but then you end up doing it anyway, so what's the point? And now I'm going to introduce another TypeScript utility, which is called partial, and you'll understand that this pattern here that we're using to validate the inputs could be quite useful, and we're going to do this with TypeScript. So for example, we know these init params are coming from some external source that we can't necessarily trust, so we may want to validate them before we instantiate this class. What I'm going to use is partial. Partial says, okay, I'm going to take this type, which if we go up to the top is make, owner, and type, but they're all required. And I'm going to make every single one of the properties on this class optional. So now when we go down to our diagnostics with the return new car here, we can see that it's saying that the argument of partial car init params is not assignable to the parameter of type car init params because it's partial. And in this case, it's saying make, the first property, is optional in the partial case, but it's required in the init params. So this means that we're saying, well, we know as it's an external source where we are getting this data from, it might not be trustworthy. So let's grab all of these out, like make, owner, and type. And then what we're going to do is we're going to ensure that all of these are valid. So we can say if not make, then we can throw a new error. And if there is no type or if there's no owner, we're going to get an error. So now we have confidence that each of these is going to be available. If any of these were undefined, meaning that they would return false here, or rather true, to say, okay, if the make is not there, then we're going to go and throw an error. If type is not there, we're going to throw an error. If owner is undefined, we're going to throw an error. So now we can say that owner, for example, we can hover over owner, and we can see it's of type string. Whereas if we were here, we would say it's of type string or undefined because of that partial keyword, the utility that we've used from TypeScript to make all of these optional. It says that this is either going to be the string, the original type of car init params for owner, or it's going to be undefined. Now we've done our validation, so we can simply pass back in the make, the type, and the owner. So by using this static method, we can call the constructor in a way that we have a lot more safety with respect to the parameters that we are going to be using. Since version 4.3 of TypeScript, they've also introduced the override keyword. The override keyword is relevant in the case that, for example, in our parent class vehicle, I've added a method called sound, and because this could be of any vehicle type at the moment, I've just put void saying that we're not interested with that particular return type. But when it comes to the car, then we want to actually provide a method. But the thing is, if we were to not use this override keyword, we're going to get an error because it's going to say that you're basically re-implementing a function or method that exists in the parent class. If you want to do this, fine, but you need to implement this override. Override's important because rather than just allowing us to recreate a method that doesn't let us know if that method is going to be used or not, then if we didn't have a method that we're overriding, for example, get sound, then we'll get a warning saying that, okay, we're overriding something, but what we're overriding doesn't exist in the superclass. Now, the reason that's important is because if you change the name of this method, it'll give you the warning in the subclass that you also need to go and change the name. Ordinarily, not something that I would use. I tend away from inheritance where possible, but it's important to understand all of these keywords. One concept that TypeScript introduces with respect to classes is the concept of abstract classes. An abstract class is a class that can be inherited from into subclasses, but it itself would never be instantiated. So this could be good if you wanted to create a base class that you would be inheriting from in lots of different subclasses. And in this example I'm going to show you is we have this abstract class of sports car, and we've defined an abstract method of skid. So we know cars can do skids, but it's incumbent upon the subclass to implement that skid method. On the other hand, every sports car gets chicks, right? So this has this method, get chicks, and it returns a number. In any case, the methods are not important. The idea is that we would never instantiate this abstract class directly. I'll show you that. So if we say that we wanted to, say, have a Porsche, and that is a new sports car, we will see that it's going to give us an error to say that we cannot create an instance of an abstract class. That's totally fine. So what we need to do instead is we need to inherit from the abstract class with our Porsche and then implement the required abstract methods, in this case skid, and then we'll be able to instantiate our Porsche. So we can create a class here with the class keyword, which is also native to JavaScript, as we know, and we can say this is a Porsche, and in here we can simply define a method, and that's going to be skid, and generally Porsches can do massive skids, so we can just return massive skid. Now we can instantiate this Porsche, and if we extend correctly, we will have the skid method that we've assigned or declared on the subclass itself, but we will also have the get chicks. So that is an implementation of the abstract class. In this final section about classes in TypeScript, we're going to talk about the implements keyword. Implements is quite nice in my opinion because you can define the shape of your class and the methods and properties that it would have on it, and then you can implement that in a class. This can be a little bit nicer than inheriting from it. It essentially is a blueprint for what you want the class to look like. So if you have an API to one third party and then you have it to another and you want to make these consistent, then what you could do is you could implement a base class with the methods that you would like to be able to interact with those APIs with, and you can then ensure that your class adheres to this blueprint. So let's have a look at an example. We said that this class is any old class and it implements the base class. Then immediately we are given a diagnostics warning saying that any old class is not implementing the base class. So we can say that we need a log method and we also need an add method. Now we're no longer getting that error, but there's one other thing that we can think about with respect to the implements keyword. we can have, for example, another interface. You'll see that above we didn't have any properties. We only had methods that we'd defined. But we can say here that we've got a thing to log. Right now we're just logging hello. And therefore we can say that we've got properties as well. So we can actually implement two of these interfaces. Now we can implement that. So we can say thing to log is string, and it's going to be hello world. And now we've got exactly the same implementation on the base class, and we've got properties, and so can in fact implement multiple interfaces. Of course, I haven't used a lot of the fancy syntax that is available with TypeScript in this example, like read-only, private, protected, public, but all of that is still applicable when talking about implements in any class in TypeScript. I've already mentioned the pitfalls of the any type in TypeScript, but it's very important to reiterate this point and delve a little bit deeper into it. The any type doesn't give us the benefits of the TypeScript language server, so we get no IDE services, we don't get any feedback on errors, and even worse than that, the any type can infect our code in a way that I'll demonstrate in a moment. Essentially, any is the broadest type. It could be anything. And so when we declare something as any, we are not narrowing it to any specific type of whether that be a primitive or some other interface or type. It should therefore be avoided. And realistically, the arguments for the use of any are probably better off being understood through the keyword unknown. Sometimes you might hear that any is acceptable because we're dealing with some kind of third-party API and we don't need to document all of the different types. And it is true that you may not have capacity to do so, and it may not make sense to do so. Imagine that you have some API response that is absolutely massive and has a lot of random fields that don't interest you. Then you can either omit those fields, or you could perhaps put the any keyword next to them in your type declaration. But perhaps a better way to do that would be to use the unknown keyword. In this example here, I'm stating that we've got a type of an external data source, and we can imagine that it's got a useful piece of data, which is an object, and it's also got some other data. The data in the useful data object is a tuple, and we're going to talk further in depth about that. It differs from an array because it has a fixed length, and therefore the element type at every index is important. Nevertheless, this data has a string, a number, and a symbol. It's been well documented by whoever was in charge of integrating this API. However, there is some other data, and whoever was documenting this simply put an any there because they weren't interested in it. Now we can see this is the shape of the actually populated data, and we've got the useful data. It's got this string here, it's got a number, and it's got a symbol, which is another one of the primitive types that are available in the TypeScript language, but also natively to JavaScript. And then we have other data. Other data looks like it was empty, or we can imagine it had any number of different fields and other data sets in it. The problem is that our original type declaration left it as any. So if we go to our external data source, as expected, we can go to our useful data and then data 1. And in here, we can get the element at 0. We can have a look at that. We can see that it is of type string, just so that you have a good understanding of how tuples work. And then at position 1, we've got a number. And then at 2, we have a symbol. So that is all very well documented. They've done a great job. But now when we go to our, rather than useful data, we go to other data, we don't have anything. And we can see, we'll console log this so we don't get that error. We hover over other data, we see it's of type any, but then we can say chain on a bunch of hellos. TypeScript isn't giving us any feedback here. Of course, we can visually inspect and see that this does not have any of those properties, and so this is going to cause a runtime error. But nevertheless, because we've used any, we've overridden all of the benefits of the TypeScript type system. This is why it's so bad to use any. However, had we used the keyword unknown, then we at least would have been presented with an error which said that external data source dot other data is of type unknown. And what that will do, will encourage us to check the type, which will allow us to have safety in our program. And if we check this and we determine that this is an object, then we can look for properties within that object and so on and so forth. In any case, it won't result in a runtime error. So that's the first piece of information that is important to understand with respect to any. And I'm just going to remove that, and we're going to look at an even more specific example here with respect to credentials. You can imagine that we need to authenticate users. And so I've created a small example program that is going to authenticate users based on their username and their password. And we're going to step into the code in a moment. But the most important aspect initially to consider is the type of any. If we had one any in our program, we would actually find that that any could infect or penetrate all the way through our code. Let's have a look at the path that this takes. User input, we can imagine we're in the front-end client. We've obtained some user data, but we've said that it's of type any, and we haven't done any validation for whatever reason. Now we step into our authenticate user. So the user input object is a parameter argument here for this function, and we pass it in. Now here, we have this creds parameter, and it's of type credentials. You can see that up the top. It's expecting this to be an object with a username and a password. Ordinarily, this would check if the type was incorrect. For example, if it was a type unknown, it would say there's a problem here if it was a boolean or a string. But because it's of type any, it is not going to throw any warnings at us. So it gets stepped into the next piece of code, which is our authenticate method on the authenticator service that I've created for the purpose of this example. If we step into that, that itself is expecting credentials. However, you can see that these username and password is being destructured. And so we're going to encounter in this moment an error that says cannot destructure username or password from property which is undefined. Something along those lines anyway. And so this is the danger of the use of any. Try where possible to never use it. In my code bases, I cannot remember the last time that I used any. So any argument about any being a necessary approach for data sets that we don't have time or capacity to use, just stick with unknown if possible. Perhaps there are cases, certain cases where any is appropriate and the amount of effort that's going to go into documenting it all is just too much, or TypeScript is being difficult and it's hard to achieve what you need. In that case, ensure that you limit this phenomenon that we've just stepped through, and that you ensure that you've got good validation in place so that this any can't infect other parts of your code. Now let's look at a few other concepts here while we're at it with this authenticate module. I'm going to uncomment this, and we are going to step through this authenticate, and there's a few new concepts which you'll be able to get familiar with here. We've already looked at the case of the tuple, which was the example in that external data source. I'm going to show you another example. As you can see here, we've got a return type and we're destructuring from an array. And this is a pattern which I use a fair bit. If we hover over rights, we can see that we've got a specific type of user, admin, or undefined. And in the case of authenticated, it's a boolean. So the way that we achieved this couldn't be through an array. As we know with arrays, if we type out an array and say that it has multiple types, there's no corresponding index with those types. Tuples, on the other hand, have a limited or constrained length, and therefore we can indicate what is the type at index 0, index 1, index 2, and so on and so forth. Going to have a look into this authenticate method now. So what we have in this file is simply a user object, which has the user names, and each of those has an associated array, which is actually a tuple in this case, which is user auth rights. So we know at the 0th index that it's a string, which is going to be the password, and at the first index we have the rights, which is going to be a type union of these string literals, user or admin. So if we hover over Boris, we can see that we're expecting a very particular property in each of these indices in the tuple. So our class gets populated with this users object, and then we can invoke this method called authenticate with our credentials, the username and password, and it returns, this is the return type here on these two lines, either if they're authenticated, it'll return true at the first, the 0th index, and in the second, it will return the user rights, or in this case, I've called it realm. Let's correct that and call that rights. If they're not authenticated, it's simply going to return false, and there'll be nothing in the rights section. So the authenticate method takes in these parameter credentials. It looks into the private users, read-only users object that we have populated our class with the username. So for example, if the username is Boris, then it will grab this tuple here. If it's Harry, it'll grab that. And if it's Daisy, it'll grab that. Of course, if it doesn't match anything, it'll be undefined, and it will default to this case down the bottom, and we will have this return false in the tuple, which is the second option in the return type union. However, if it does have a match, it's going to strip out the password and the rights, and it's going to check the password against the provided passwords in the credentials object, which is here. And if it's a match, it's going to return authenticated true along with the rights. Very simple program, but it's using a number of aspects of TypeScript which are new to you, or are possibly new to you. The first thing I want to point out is this record string. I've kind of glanced over it, but it is an important and very useful utility type in TypeScript. What it is, it's a utility type that allows you to create an object, and this is going to be an object of any size, and all of the keys are going to be strings. It actually allows you to create this with the either number or symbol as well, if you'll see here. But in our case, we are creating an object with Boris, Harry, and Daisy, and they're all strings. And then this object has, for every corresponding string, which is a key, a user auth rights. And the user auth rights are the tuple that we mentioned above, which has password and it has rights in it. Now, I wanted to demonstrate what this looks like in the interface syntax and then also in the record syntax. You can see here that the record syntax is much less verbose. It's very slim, and I find it to be one of the most useful utilities in TypeScript. But we can achieve the same thing, and perhaps it'll make more sense for a beginner if we look at this interface. This users object, which I'm using here, is exactly the same as the record string user auth rights. What is it? What it's saying is that we've got an object and it has keys which are of type string, and then once again it has the same corresponding user auth rights values. So we can achieve the same result in two ways, and you've noticed that probably already in this TypeScript tutorial that you can do that. Here we've introduced a few new concepts like record, tuple, and along with that, the discussion around the any and unknown keyword should clarify many things. If our user is authenticated, then we can simply proceed, or in this case, because this is just an example, we're going to log out that this is the username and they're authenticated and they have these rights. If not, we're going to tell them to get out. Let's run our program for the sake of sanity. And you may have noticed that during this tutorial, I almost never run the program. And that is something which you'll get very used to if you've come from JavaScript. I remember the first time that I wrote a TypeScript program and I didn't run it the entire time, and at the end it just ran without a problem. And this is a very big difference from JavaScript, where you're constantly running to see if you're encountering any runtime errors. But the fact is that TypeScript catches almost all of these errors if you're adhering to the rules and to the best practices that I've been taking you through as part of this tutorial. So let's run our program. I'm going to use tsnode as I did before. I'm going to run this program, and we can see that Boris is being told to get out. Now, if we go into our auth, we can see, well, we've got Boris is admin1234, Harry is daddy hurt me, and Daisy is this as a password. Why don't we use Harry for a change? So daddy hurt me. We can come in here, we can change this to Harry, and we're going to run our program again, and we can see that Harry is authenticated and he has the rights of user. One of the more recent introductions to TypeScript has been this concept of decorators, and I'm going to walk you through an example of decorators using our auth class. Decorators can be useful for a number of purposes, and they can be used not only on methods but also on class properties and even parameters. In this case, we're just going to be using it on a method, and that method is called delete user. This is a new method that I created, and this method allows us to pass in the user who wants to delete another user, and the second parameter is the user that we want to delete. We log that we are deleting the user, and then we delete the user. Before we get too much into the code on the right hand side, I'm just going to show you a few minor changes that I've made to our original authenticate user function. So this code is largely unchanged, but instead of just logging out whether the user is authenticated and what rights they have, we're now returning a boolean, true or false, depending on the outcome of whether they are authenticated or not. So you can see the return type on authenticate user, which was previously void, has been changed to boolean. This makes sense because we want to use it down here in our example within the context of this if statement. So here, if our authenticate user returns true with the input that the user has provided above, in this case Harry has the password of daddy hurt me. So if this matches a user and the password checks out, this is going to return true, and then we're going to be within the scope of this if statement. Otherwise, this will never get executed. If we do get in here though, we're going to try and get Harry, in this case, to delete the user Boris. However, if you recall into our small database, our little miniature database, Harry only has a user rights type of user, and he's not an admin. So you can imagine that in a system of different privileges and accesses, we would have users, admins, we may have all or any number of different levels. However, for this example, this is sufficient to have 2. And in this case, we're saying that admins can delete users, but users can't delete users, and they certainly can't delete admins. So as you would have perhaps seen, we've got this additional syntax above our delete user method, and this is prefixed with this @ symbol, which indicates that this is a decorator. And so this is the syntax that we use when we want to wrap a method in the class with a decorator. I mostly use decorators in the cases of validation. We might want to check and validate the parameters being supplied to a function, and if these parameters don't meet the requirements, we might want to reject out, or otherwise we might want to call the function, say delete user, and then we may have another method which simply logs or checks that the delete user operation was successful. So logging and validation are great purposes for decorators. They are somewhat divisive within the TypeScript community. People have different opinions, and they come, of course, with great inspiration from other languages. Ultimately, this example will give you the confidence to see a decorator and understand what's happening, and be able to use your own judgment as to whether you want to use decorators in your own code. Decorators take these 3 arguments. The first being the target, which is the inherited object. So in this case, we've got this delete user, and it's inheriting from a type of object. In this case, it's not that important to us. We also have the key. The key is simply going to reflect the name of the method that we are wrapping with our decorator. So in this case, it would be delete user. And finally, we have the descriptor. And the descriptor is important because it has a bunch of properties associated with it, and we can use those properties and we can override or reset them. So in this case, we have this original method, and if we look at the descriptor, it has a bunch of different properties on it, but one of those is value. And actually what value is, it represents the actual method that would have otherwise been called. So in this situation, what we're doing is we are assigning the original function to this constant, and we're saving it there because we're going to use it later. And then what we're doing is we're declaring a new function which inserts some additional logic, and then at the bottom applies the same context from the class to the original method with the same arguments. You can imagine that you may have a database lookup call in here, or you may have logging, or you may even manipulate some of these arguments and then apply them into the method that we're calling. So you may want to serialize something, or in our case, what we want to do is we want to ensure that the user who is calling this function delete user is indeed an admin, and if they're not, we're going to error out. One important thing to note here is that we've got this keyword, and this keyword actually refers to the class within which we're going to be calling this decorator function. We can delete this auth here, which, as we discussed earlier, enums and also classes are both type space. They exist in type space and they also exist in value space. So if we didn't pass or tell TypeScript that the context here with this keyword refers to the auth class, it would not be aware of the fact that this user's property exists, and so by default it would say this is any, and it would give us a warning. However, in this case we can simply use the type of auth and apply it to this keyword here so that we know that we're dealing with the context within this auth class. And then now what we're going to do is we're going to get the username of the admin, or rather the user here, just to be consistent. So we've got this user, and just for absolute clarity, down here, this user represents the first argument in the parameters that are being passed to the delete user method, the second being the user to delete. And this array, or in fact, in this case it's a tuple, but remember that when we transpile this code, tuples just simply become arrays in the JavaScript that we're going to be running. This user is a string, and the user to delete is a string. This user to delete at this stage is not important because we're going to be performing the delete operation within the method itself of delete user. But we do want to grab out the user in this case from the arguments, the calling user. This is the user who wants to delete another user. And we're saying, okay, we're going to look into our mini database, which refers to this property down here, users. And we can have just a quick look at that for reference. Up here, we've got our mini database, and it's got this users, and it's got 3 users in it. So that's been attached to the class of auth. And we can say, okay, look into this users database with the username of the caller who wants to delete the other user, and return the associated auth user rights. So that was the password and also their rights, whether they're a user or an admin. If we don't get a match, just return an array. The reason that we return an array is so that when we destructure it, we don't have a runtime error. We can see what that looks like. If we were to delete that array, you'll now have a diagnostics warning saying that you are trying to destructure a type of auth user rights or undefined. You can in fact destructure the nth element of an array and it won't throw an error. It'll simply be undefined. So if you tried to access the 88th element of this array, it would just be undefined. So by including that, saying if this is undefined, we haven't got a match in our mini database, then we're going to default to an array. We can then destructure safely. So in this case, we're not concerned with the password, which is going to be the first return element in this tuple, which we had above, so password here. But we are concerned with the rights, and the rights are going to be either user, admin, or if we don't have a match, they're going to be undefined. And then what we're going to say is, okay, if the rights are not of type admin, they don't match the admin string literal, then we are going to throw a new error. But if it does match, that is to say that it is an admin, then we are going to call the original method with the same context of the auth class and the original arguments. Finally, we're going to return this descriptor. And so that's how we're going to wrap our delete user method with this validation. Okay, so let's run this and we'll see what we're going to get. But let's just step through it one more time. We've got a user input, and in this case, it's Harry logging in. He's providing the password "Daddy hurt me." So he will get logged in because this password is a match. We pass that into the authenticate user. It's going to call the authenticate method on the auth module, and it's going to tell us if he's authenticated. If he is authenticated, we're going to log that out and we're going to return true. Otherwise, we're going to console log get out. We're going to return false. So in this case, we should expect that Harry, who's got a user rights type of user, will not be able to delete Boris because only admins are able to delete Boris. And therefore, we are checking that with this ensure admin decorator on our delete user method. Let's try this out. So we'll run it. And we've encountered an error. We can see that Harry was authenticated. So we got to this step and we did step inside here. However, then we encountered an error. It says only admins can delete users. So this is working as anticipated. Harry is a user, not an admin, so he can't delete Boris. We can, however, see that Daisy is an admin. So let's get Daisy, and we're going to change the username and also the password. And we're going to try to delete Boris again. Boris is a user, Daisy is an admin. And let's see if we can now get inside the method which we failed to do when we were logging in as Harry. When we were logging as Harry, just one more time to make it absolutely transparent, we got into our decorator, we encountered an error, it errored out, and the original method never got called. Okay, so let's call our script again, and we can see that Daisy is authenticated as an admin, and she's deleting Boris, and there's no problem that's been encountered. So that is an introduction to decorators. It's now time to introduce one of the most powerful features of TypeScript, and that is generics. Generics allow you to dynamically create types and to pass arguments into your types at the time of creation. So it reduces the amount of code that you need to write, and at the same time allows you to build really complex types that suit your data structures. The good news is we've already been working with types that are generics. For example, we've been working with the built-in array type. So let's just have a look at that and we'll explore how the generic array type works. We can use the type keyword. We're going to say array of hours. And this is going to be an array, and we're going to simply pass in a string argument at the moment. If you recall, there's two ways to stipulate that something is an array. You can either do this, or you can say string and then use the square brackets. However, ordinarily, when it comes to generics, we are passing in arguments within the greater than and less than symbol that is made available by TypeScript. So I'm going to stick with this syntax for now. The idea with generics is that if we hover over this array, for example, we're going to see that it takes an argument of t. And t is simply the convention in TypeScript that if you're passing in a type argument as a generic, then we use a capitalized T. If we have more than one, we can use other capitalized letters. And in the case of keys, we typically use K. Rather than just have an array of strings, I'm going to say that we have an array of tasks. So we're going to create this new thing. It's going to be called a task. And a task is a type, and it has a due date, and that is of type date. It has a name, and that is a string, and it has a difficulty, and that is a number. We'll say it might be from 1 to 10 or something like that. Now, instead of just passing in string, array, because it takes this capital T, actually takes any kind of generic argument. So we can pass in task here, and all of a sudden we have a typed array of tasks. That's pretty cool, but we can actually build on this further. In fact, we might want to have custom tasks. So let's say that we've got this due date, we've got a name, and then we've also got the difficulty. But a task may also have some additional information, like instructions. And the instructions might differ in terms of its shape. So let's say that we've got instructions, but rather than declare it here, we're going to say it's type T, and we are going to pass in T. Now we're going to get an error down the bottom because we're expecting to pass in an argument to our task where we're using it in the array. Let's use two different types of instruction. In the first case, we're going to imagine we've got an excellent boss or colleague who are giving us the instructions. The instructions are very clear, and they've got 3 fields. And in the second case, we're simply going to assume that the instructions are very unclear. They're an array of mixed types, something that we ordinarily want to avoid in any language. So let's create our first type, and it's going to be clear instructions. It's an object, and so it's going to have step 1, and it'll have step 2, and it'll have hints, and it may even have contact person in case you get stuck. So now with these clear instructions, we can pass this into the task and we can say, well, this is a task with clear instructions. So if we were to go and create a new type, which we're going to extract from this array of ours. So let's just say we want to get this type and it's going to be a task with clear instructions. Then we can say array of ours and we can access that with a number. Now, if we hover over this, we can see that we've got the structure and we can also see that instructions is clear instructions. But sometimes instructions aren't clear. And so let's create a new type and it's going to be unclear instructions. And this is simply going to be an array and it's going to include null. And if we're lucky, there might be some strings in there which are going to give us hints as to our task. So what we can do now is we can say, well, here in this clear instructions, we want to create another option and it's going to be u. And this is going to be the unclear task. And the instructions are actually going to be a union of t or u. Now in here, it's expecting a second argument, and so we can pass in unclear instructions. Now when we hover over our task with clear instructions, we're going to have an issue because no longer is our task necessarily just a task with clear instructions, but it's a task with instructions that could be unclear. The thing is that this structure at the moment doesn't give us a lot of clarity. It doesn't give us a lot of confidence because we've ended up with this union and we're going to have to ultimately check whether we're dealing with an array type or we're dealing with this clear instructions object type. So what we can do instead is we can narrow it down to a single task argument. And in here, we can say that this is narrower than t, which, by the way, if we were to just have a look at this for a moment, we're going to hover over t. We can see that t could be actually anything. It's just whatever is passed in. But we want to be a little bit stricter and we want to say that, well, in fact, we want t to be clear instructions. And we can do that by saying it extends clear instructions. But we ultimately still have to deal with the case that we are dealing with unclear instructions. So we're going to make it a union. And now down here, we can pass in within our team at work. We know that we only deal with clear instructions, for example. So then we can pass this in and we can say array of ours is now an array of clear instructions, or it's an array of unclear instructions. Both are totally fine. And if we hover over the extracted type, we can see that we've now narrowed it down because earlier we had ended up with having to pass two arguments and then we'd end up with this union and we'd have to differentiate between the different types of instructions, and we no longer have to do that. So this generic is a way of building our types without having to repeat ourselves. As you can imagine, without this generic type, we'd have to have created a task here and called it task with clear instructions, and then in the instructions given it the exact type and then created a new type declaration with unclear instructions. And that obviously becomes extremely verbose. It's a waste of time. And so you can see the power of generics immediately. I mentioned that we've been using generics already. And in fact, the array was just one example. We've also used record when we wanted to create objects that had strings as keys, and we could pass in any second argument as a type argument for the value on the field of the object. We're just going to have a look at that one more time. So we'll say that we have a type and it's going to be an object of data and it's going to be a record. So if you saw this earlier, record takes two arguments, type arguments, and so we can create an object type right like this without having to declare an interface. If we hover over type of data, we can see that this is an object of data. It has strings and then associated numbers. So in the case that we don't know what the string is going to be, it might be, for example, a unique ID. We can never predict what it is, and it has a number associated with it. We can pass into record other types. So we may have something like, so we may have another type like, say, river. A river has a depth, that's a number. It has the width, that's a number. And it's got a length, it's a number. And so we could pass in this river into the record type, and we might say that this string is indeed a name. So we might say, we saw this earlier, that this is a benefit of the type alias. So we can say river name and river. And now when we hover over this, and we're going to rather call it, rather than object of data, we're going to call it object of rivers. We can hover over this, and we can see that we have this string as the name, and we have rivers. So it's an object. You can give it any number of rivers. You could give it the Nile, you could give it the Danube, whatever it may be. And then on the other hand, you've got the depth, width, and length of that associated river. So this is where a built-in utility is indeed actually just a generic. We've seen with record that K here, which represents a key, extends either a number, a string, a symbol, and as the second type argument, it takes the capital T again, which indicates a type of any type. This is just one example. Now, let's say we wanted to have something which is a little bit less strict. We don't necessarily know the depth and width and length of every single river that we're going to record in our database. However, we do know that in some occasions we've got the depth, sometimes we've got the width, sometimes we've got the length, sometimes we've got all of them. But nevertheless, the data associated with the rivers that we're collecting is all important, and we don't want to throw away data just because we don't have everything. In this case, we can use the partial built-in type. What this does is it says, okay, we've got a partial river, and so if we create here the partial river, we're going to strip this out once again, and this is going to be an object of rivers, and we know that the key here is string, so we can access this with the string type. And in here we can see partial has made every single one of these properties to be possibly undefined. And so rather than having had to create that twice, the partial has allowed us to manipulate our existing type, in which the original river type, every single field was required, and now we have made it so not all of these fields are required. But if we wanted to reverse that, we might say, well, actually, we need something that is required. In our case, we're actually only dealing with required data. And in the case that we don't have access to the declaration where type river was made and partial was applied, well, we can simply include this built-in TypeScript utility type called required. And now, if we go and hover over our partial river, we're going to see that everything is now required again. So generally speaking, in the case of read-only, we can see here that we could even chain this further. So at the moment, we've got this type river and it's got these fields, but we could actually change those fields. For example, let's create a river, and we're going to say that this is a required river, and we're going to say river is required river, and we're going to say the depth is going to be 100, the width is going to be 500, and then the length is going to be 10,000. So if we hover over this river, we can see that it's required, and if we go to all of these fields, we can access this here. We can say river.depth, and that is a number, width is a number, and length is a number. Of course, if we go back to our original example, where it's partial, and we haven't made it required, then depth, of course, could possibly be undefined. And so all of these fields are either of type number or undefined. But let's undo that change that we just made. So we know that it's required, but we want to make it even stricter, because at the moment, if we said river.depth, actually we've got some new data and it's 90, not 100, it's not going to complain. So we can use this other built-in TypeScript type called read-only. And by applying read-only, and let's hover over the type, we can see that we've now got properties within the object which are not only required, but they're read-only, which means we can't change them. We can only read these. And so when we go to change this, we will in fact be met with an error with TypeScript. It's going to say that we cannot assign a new value to this read-only property. So let's get rid of that. Now, important to note, of course, in TypeScript, as always, we can just apply an @tsignore, and this error is going to go away. And this is, of course, goes without saying, bad practice. We don't want to do this, except in very particular situations, you should never really have to do this. There may be a very, very rare occasion where you need to use tsignore, and in that case you should use a narrower version of tsignore. We've talked about record, and the next two are my absolute favorites, because sometimes we create a type and we want this to be a kind of base type and it has tons of information. So let's say rather than just the width, length, and depth, we've also got a name, and that's a string. Then we've got a local name. Maybe the locals give it another name. And then we have the type of fish that live in the river, and maybe that's a string, it's an array. And finally, we might have the pollution, and we might say that's a pollution level. And then this we're going to just say is a number. And so you've got a pretty big data set, and you can imagine in the real world when you're dealing with data that you end up with dozens, in some cases more fields on your specific type. And so sometimes you don't need all of those. You want to be optimal with respect to the data that you're passing around. You only want to, say, grab the name of the river, and then you might display the name in the front end, and then later when the user clicks on the name, you could go and fetch all of the other data. So what we can do in that case is we can say that this river is not just a required river. Actually, we just want to pick the most useful information. So in this case, I'm just going to say pick, and then I'm going to say from required river, or let's just kind of make this a little bit easier to read. So from river, and I'm just going to remove all of this, and we're going to pick off the river. We're just going to get the name, and we're also going to get the length. Our front-end team, all they're asking for is the name and the length of the river. And if people are more interested, then they can simply ask. Now, of course, we've got too many different pieces of information here. So let's just give this river a name, and we're going to call it the Danube. So now what we've done is we've not had to go and create a totally new type for this narrower type of river that we're going to send to our front-end client. Rather, we have created a type from that river type that is narrower and only includes these fields, name and length. Just like in the case of what we had with respect to partial and required, we also have an opposite, an inverse of pick, and that is omit. So rather than saying that we want to just pick certain fields off river, we might say instead that we want to omit certain fields from the original. And so we may say something like, we want the name and length, so that is not going to be appropriate. So we want to get rid of the depth though, and we want to get rid of the width. We want to get rid of the local name, and we want to get rid of the type of fish. But let's say we want to keep the pollution level, and the pollution level is going to be pretty low. It's say 2. We can see that we're missing a few bits of information, so we've got to use omit to begin with, and actually we had the right set. So here we can see the example of omit on the right hand side in the documentation, and here is our implementation of omit, which is slightly out of the page there, but you get the idea. So we've taken that original river type declaration and we have said, well, we want that original, but we want to omit certain fields from it. Now, my favorite TypeScript utility is pick. I don't know why, but I always tend to use it. And so what we're going to do is we're going to recreate pick. We could recreate any of these, and I would suggest that you go ahead and you recreate one of the TypeScript utilities. But this exercise helps us to understand that generics at the end of the day, and all of these built-in utility types, are just TypeScript, and we can in fact create our own utility types that will help us build our dynamic types and have a really nice TypeScript code base that represents exactly the shape of our data. So I'm going to create this custom pick, and the test here is we've already declared custom pick on River, and it's going to behave in exactly the same way that pick does. It's going to take a type, in this case River, and it's going to grab the keys, name and length. So we should end up with an object which has name, and that should be a string, and length should be a number. So let's declare our custom type, and we're going to say it takes T. So recall capital T indicates our type, and then it takes K, and I'm using K because I want to represent the keys in the river. So it's going to say k extends, and it's going to be key of t. So what I'm doing here is I'm saying we've got this type, which is going to be an object, and then we have the keys that belong to t. What we want to do now is we want to return an object, and this is going to include all the keys. So we're going to say that it's going to be each one of the keys in the k that we're passing, and then that is simply going to be the t, and then we're going to reference it with the k. So let's go and see what we're getting with river. We're not getting any complaints whatsoever, and we can hover over name, Danube, and length of number. If we were to change this away from being a const, let's rather just do away with all of this, or do away with what we can. So let's say I'm going to call it slim river data, and we're going to then get away all of this. So now we should have the ability to hover over this type, and we can see what's in there. We've got string or number. So we have made a mistake actually in our implementation, because this is not tied to the name should be string and the length should be number. So let's come in here, and if we change this to small k, we're going to hover over this, and we can see that we now have the name and the length. So in that case, what we were doing is we were referencing the union of all of the keys, that it would be name and length, and then we were saying that was the type associated here. Whereas the small k represents one of those keys in this union of keys. So for example, in the first iteration, it would go through, it would say name, and then it would say length. And so by referencing the small k here, we're getting the exact type that is associated with name, and then we're getting the exact type that's associated with length. So that's just an example of a TypeScript higher utility that we have rewritten ourselves, and in code bases that you use, you'll probably end up rewriting any number of these, or creating at least your own custom utilities and TypeScript generics. TypeScript has a concept of conditional types, and these can be very useful if we want to make a determination on our types based on what certain parameters are that we're pushing into functions, for example. And ultimately what conditional types do is they help us to understand the relationship between our types. It's important to point out that the syntax for conditional types is very close to JavaScript's ternary operator. So you can imagine there are no if statements in TypeScript, but this is the equivalent of an if statement. We may make a determination that if we have a certain type, then our output type may be of a certain type. So we're going to walk through this example, and it'll help really clarify this point. In this example, I've got two interfaces that I've created. One is called ID, and it's an object, and it has a property on it, and it is called ID, and it has a number. The other one is called name. It has a property of name, and it's a string. So these are very basic objects, and they are different, however, because they have different properties, and those properties have different types. Now, the important part here is this name or ID, and this is our conditional type that we have implemented in TypeScript. So what this is saying is I'm a generic, and if I receive a type of number, then I'm going to assume that we are going to be an ID. If I receive anything else, in this case we're extending number and string, then I'm going to assume that I am a name. And the best way to clarify this is, of course, with an example. So if we look at this name or ID function, we can see that it takes a generic, and it is t, and it says, okay, I as a function have a single parameter, and it is of type t, which extends number or string, which means that it can be one of number or string, the union of number or string. And then based on the input type, I'm going to return another type. So we can see here, if we hover over this, that we've got this name or ID, and it is passing that t, which extends number or string, into our type alias, which is our conditional type. So if we have a look at calling this function, it'll help us to understand exactly what's happening. in this case, we are calling name or ID with a string, which in this case is TypeScript. If we hover over the variable, we should now expect that this function would have taken t as a type of string, and then it would have passed the t into our conditional type return type, which would have determined that this is a string and therefore we're going to return name. So we should now hover over our TypeScript and we should see that it is of type name. And if we go and we have a look at this TypeScript object, we can see that it's got a name on it, which corresponds to the interface that we've declared above. The same thing should happen with this float down here. So we're calling the same function but with a different type. In this case, we're calling it with a number. And therefore, based on this name or ID generic, we're passing in a number. Then we're passing that type into our conditional operator. This accepts numbers, and it says that if the type that is being passed in is a number, then we're going to return an ID. You can imagine in this section here where this error is being thrown, there would be a lot of logic in here, which would ultimately build these interfaces that we're concerned with. For the moment though, this is just an example, and I want to show you the relationship between the input type in the parameter and then the return type. So we can hover over float and we can see that it's of type ID. So that's how conditional types work in TypeScript. But there is one more thing I'd like to point out. And that is, let's imagine now that we wanted to create another variable and we're going to call that bool. Perhaps we're new to the team and we, despite the name of this function being name or ID, we think, well, perhaps this might take a boolean. As you can see, TypeScript is giving us a warning. So we're going to have to add on here the type of boolean. Now, this is going to not give us any warnings. And so we can have a look in here and say, okay, we're passing in name or ID, a parameter of true. So let's walk through this. This type, which is being passed in, gets passed into this generic type alias. And if we look at this generic type alias, it says that it accepts either number or string. So there's no Boolean case here. And that it extends number, that is to say that if the type being passed in is a number, it's going to be an ID. Otherwise, in all other cases, it's going to be a name. So let's see. If we hover over bool now, we're going to see that bool is of type name. It's not of type bool, but really this is not accurate. We could have assumed certainly that there is no interface bool up here, and so that is somewhat expected that we haven't received an interface that we haven't declared. However, really this should never occur. And now I'm going to introduce another concept in TypeScript building upon this conditional type. And so you can imagine in TypeScript there are no if statements and if blocks, but we can chain these ternary operators here, these conditional type syntax, and we can say, okay, if t extends number, then make it a type of ID. If t extends string, then make it a name, and otherwise make it of type never. Just going to format that, and now we can just have a look in here. We do need to provide the Boolean type in here. Now TypeScript is not complaining, so we do need to provide the Boolean type here because the type that's being passed through is in fact a Boolean. But this is just for demonstration purposes, of course. So now if we hover over bool, we have got to understand that name or ID would in fact now take this parameter argument of number, string, or boolean and then pass that type into name or ID. And now I admit that the syntax is not great in TypeScript for these conditions, but if we just walk through this one more time, we can get any one of number, string, or boolean. If t extends number, that is to say if the type extends number, we're going to get that ID interface. If it extends string, we'll get name. Otherwise, we're going to encounter never. And what never is in TypeScript is it indicates that this should never occur. We should never actually reach this point in the types, and therefore, if we hover over this Boolean, we should see that actually this should never be allowed. In fact, in the real world, what this would suggest is that in this function here, name or ID, we would likely throw an error because The first step you can imagine is check if it's a number, then create the ID object and return that. Check if it's a string, then create that, otherwise throw an error. So you can see how this conditional typing works, and it helps us to make a determination between the relationship of these types on a conditional basis. Congratulations, you've made it all the way here, and we've covered a lot of different content. I'm sure that by now you will be feeling really confident with the TypeScript language, and hopefully you will be encouraged about using it in future projects and also feel less anxious about jumping into TypeScript projects, given that we've introduced so much of the syntax that TypeScript introduces on top of native JavaScript. This last section is not for the faint of heart. I am going to bring many aspects together, so don't be discouraged if you need to watch this a few times. Of course, nothing would be complete without using promises when it comes to JavaScript and TypeScript. So as far as the course goes so far, we've only been working with synchronous code. We're going to be introducing async await, but this is really straightforward if you've used this within JavaScript. However, I also want to leverage the power of conditional types, and I want to show you how we can use conditional types to create a program which is basically going to be a script. It's going to read from our local file system two different file types with two different types of data, and we aren't going to have to keep checking for which one we're working with. We're going to be able to use TypeScript and TypeScript's conditional types to determine what the type of data is that we're working with. Before we get started, you will need to install the types for Node, and that is because whenever we have some associated JavaScript, we do need to install the types if they're not natively baked into that library. In the case of Node, it's not. So what we can do is, in my case, I'm using pnpm, but if you're using yarn or npm, it's going to be the same. You can simply install the types associated for Node. So I'm just going to say pnpm save dev. We always save the types to the development dependencies because obviously when we transpile the code, all of that stuff with respect to types is thrown away. It's not available when we run it. So we don't need to save it into our dependencies. We can simply save it into our dev dependencies. And then in here, we're just going to just say types and Node. So run this just to make sure that you have the Node types available. Otherwise, TypeScript is going to complain that you don't have it. So in front of you, you can see this file. I've called it promises.ts. And what it does is it imports an API from this API file. The API we're going to explore in a moment, but I'm just going to print it out and give you an idea of the kind of data that we are going to be working with in this section. So if we now say tsNode, we're going to use tsNode so we don't have to transpile it into JavaScript in order to run it, as we've been doing throughout this course. And we simply say that we want to run this file, which is called promises.ts. We can see that we get this table here. We've console tabled this leaders.getData. So this is a bunch of leaders. We've got their age, we've got their country, and we've got their type of leadership position. And that looks all well and good. But we also, in this case, have some CEOs. And I'm just going to show you what the data looks like with respect to CEOs. All right, so CEOs, it looks like we don't have quite as much data. We simply have the names of the CEOs. So it must be an array. We've got each index here. We also have the indexes here. So they're both arrays. But in one case, we're dealing with an array of strings. And in the other case, we're dealing with an array of objects. Now, the really powerful part about TypeScript in this case is based on the file that we are reading from. So if I hover over the CEO file, we can see that this file is called ceos.json. And if I go to the leaders file, you're going to see it's leaders.json. We'll get to that in a moment when we step into the API. We pass this file into this init method available on this class, and then we get back our leaders. And you can see that it returns a generic. In this case, it's an API type, and it passes in that string literal. Now, based on that string literal, if we hover over the data which is now available within this API, we can see that by passing in ceos.json, we get an array of strings. So if we change this to be world leaders, and then we hover over get data again, we can see now we're actually given an array of leaders. So TypeScript is picking up through conditionals the exact type of data based only on the file that we're reading from. Just a quick side note that TypeScript introduces a lot nicer import syntax. So what you're seeing here is simply the TypeScript approach to importing, and we're going to do a final wrap up where we talk about TypeScript settings, including modules and importing and exporting with respect to the settings that are available. But I just wanted to point out that's why the syntax is different, and this is, however, the same syntax that you've been seeing throughout the course. And we can use this as keyword, I just wanted to mention, so that we can reassign this world leaders file to just be simply file if we want to rename it. All right, so now we're ready to step into the API and see how this is working under the hood. Right before we do that, however, I'm just going to quickly go and have a look at those files that we were reading from. So just to make it really clear the kind of data that we're working with, ceos.json is simply just a JSON file, which is an array of strings, and they're the names of these CEOs. And then if we go to the world leaders, this one's called worldleaders.json, and it's got this array of objects. So you can see that we've got all these different objects, and then we've got the name of the leaders, their age, country, and then the position that they hold in terms of leadership in their country. So just wanted to quickly show you that. Now, TypeScript obviously has all this great in TS server support, the language services, so we can simply go to the definition for this. We don't need to search for it or whatever. You'll have that option within VS Code. By now you should have discovered that. In my case, I just best use a shortcut and it takes me there. And now we can have a quick look at this class API, and we can see what it has available for us. We can see that it takes this generic type, and that generic type extends either the leader file, which is this string literal world leaders, or a CEO file. So this is what we're passing in here, and in terms of the generic type argument, and we can see that that was the only flag which determined what the get data method on this class was returning. So if the class was passed the CEO file, then we would return the format associated with CEOs. If it was passed the leader file, it would pass back or return the data in the shape of the leader associated data. We can go to the top and just quickly have a look at what that data looks like, because of course we have created the shape of the data using a type alias. So in the case of leader, we know we've got name, age, country, and type. And you can imagine that if you were working with raw data sets, then you would do something similar. You would get a grasp for the general structure of the data, say in a CSV file or a JSON file, and this is how you could type it out. In the case of the CEOs, because they're simply just a string, an array of strings, then I haven't assigned that a type alias, although we could. And then here, because CEO file has been declared at the top along with world leaders file, this is the path to that specific file. I'm using the typeof keyword to grab the type. So here we can see that if we hover over this const, then it's a string, but specifically it's been narrowed down because we've used the const declaration that it's ceos.json. If we said world leaders, then of course we're going to get that exact string of world leaders. Of course, if we said let, then we hovered over this, we're going to have a problem because this is all going to break down because we're not using that exact constant. The next item that I want to discuss is the actual conditional operator. So we just saw in the previous section a very basic implementation of a type TypeScript conditional, and here we have another conditional, and it's really not that much more difficult to understand. But in this case, we say that we're passing in this generic type, and if that type is of type leader file, that is to say that it's this exact string which points to that file, then we are going to have an array of leaders. So objects in this array are going to be the type of leader, and if not, we're going to have a string array, so all of the names of the CEOs. Great. Let's go back down to the bottom here, and we see the function that we've called, and that is this init function. Now, it is a static function. As we discussed in the class section, that means that we can call this function without instantiating the class. This is always available to us. And I've done this because this can be a little bit easier sometimes when we want to set up a class. We want to grab some data in this case, and then we want to check that data, validate it, and then pass it into our class instantiation. We've added the async keyword just like we would in JavaScript. And so we can see that we're working with promises here, because we have a function getData which returns a promise which we need to await for in order to unwrap that data. If we hover over getData, we can see that promises, just like we've been discussing in this last section of the course, are simply a generic. So here we have the promise type, and it wraps what is being returned, which in this case is unknown. And I discussed that earlier, that we generally want to use the unknown keyword over any, because any is the most flexible, and therefore it can be quite dangerous to work with it because we're not going to get any of the TypeScript language service support, whereas unknown forces us to conduct certain checks that will prevent the runtime errors. So we can just have a look here at getData. Once again, we see that promise wraps the return type, but if we hover over the variable that has awaited the getData return, we can see now that promise keyword no longer wraps the return type. So the init function is called, and it's called with the path to the file. We know that the path to the file can be either a CEO file or a leader file. And of course, if we were to pass some other string, it's going to give us a TypeScript error because we haven't set our system up for that specific string. Now we can go into this getData, and we can see what this is doing. All this is doing is it's got a return type of promise here. That's how we would declare that. And it is returning a new promise that either resolves in the case that we can grab the data out, or where there's an error, we're going to reject and then fail. So that's just standard promise syntax, nothing really to add there. But the important part of this aspect of the code is that we are using the fs read file module. Of course, if we didn't have the TypeScript package installed for that, then we would be getting a warning here and we wouldn't have type support. So that's why at the beginning it was important to install the TypeScript node types. And all this does is it just goes to the path to the file, which in this case, the getData is not too concerned. Its job is to simply read files. So we've made this reusable. You can imagine that this might be used in many places throughout the code base. We don't need to restrict it in this case to being a CEO or world leaders. It can read any file in our local file system. And all it does, it just grabs the data, it passes it, and you can just ignore this toString, or if you're familiar with JavaScript, you'll know that this returns a buffer. If we hover over this, we can see that we've got a buffer. TypeScript is giving us all of the information associated, and one way that we can convert binary buffers into strings, in this case into JSON string, is to simply use this toString method that is attached to buffer. We can see all of the attached buffer methods here because we're using TypeScript, and just want a bit of a side note, that's how we would get this into a readable format. Okay, so then we just get the data and we just resolve this promise. So let's go back to where we were calling this, and these two functions, by the way, this is a function which is outside of the class, just to be absolutely transparent, and this is a method attached to the class. So the naming here is perhaps not great, and I will just say just going to change the name so we can be more clear. Now, so get data is simply reading the path, and it's getting the data out. And if we hover over it now, it's of type unknown because that's the return type, and this is very strict. The unknown keyword is interesting in the fact that we can assign anything to an unknown variable, but anytime we want to access that unknown variable, we now have to check because we don't know. It's unknown what that variable is or any properties that it has. Is it an array? Is it an object? So unknown is very restrictive, and it forces us in this case to validate our data. So validate data simply takes the data object but also takes this generic type. Let's step into that and have a look at what that does. So this says, okay, I'm expecting the CEO file or I'm expecting the leader file, and based on that I'm going to use that TypeScript conditional to determine what kind of data I'm returning. So the first thing it says, if the data is not an array, well, neither of these is going to be valid data because we know that the world leaders, they're in the shape of an array, although they're objects in an array, and then the CEOs, they're also an array, but they're strings in an array. But in this case, this is not going to be valid data if it doesn't pass this array check. And we can see down here that if we don't, we're going to throw an error. So that's the first check. The second check is to say, okay, the data should have a length because it's an array, and if the type of the data at the 0th index, that is the first element in the array, is a string, then we know that we're dealing with some CEOs because we know that the format of CEOs is going to be an array of strings. And then secondly, data.length and the type of the data is object, then we know that we're going to be dealing with these country leaders. Now, just a side note, null is also an object in JavaScript, so it's important that we would do more checks in real life. But the point of this exercise is just to give us an example of how we would approach the is operator in this case, and here to make a determination to tell TypeScript we've done this validation and therefore we are confident that we're now dealing with this type. And we've covered the is keyword, but it's just interesting to see its implementation again. I tend to use it quite a lot when it comes to validation because it allows me to do things like what we've done down below with this is valid data, to create a function that we can perform validation on. We perhaps want to throw an error even inside that function if we have not had that data in a certain shape, or the type of the data being passed doesn't adhere to certain specifications that we need. So next we say, okay, if this passes, now we want to instantiate our class with that associated data. And we're going to get into that next step in a moment. One quick thing that I do want to point out though is, okay, if we say that the validation doesn't pass, then we're going to throw an error. And here I've got a custom error function, and I just wanted to point out the use of never again, because in this case, when we have a function that is throwing an error, this one takes a message, it console logs, and then it throws that error. So the return type isn't void. Void, you would say, well, we're not interested in the return type, so let's throw it away. Here, in this case, actually the return type is never, because we can never actually access this return type. Even if we wrapped this in a try-catch error, we're going to receive this error that's been thrown. We're never going to be able to access the return type of the function. So here is another use of the never keyword in TypeScript. I just wanted to use that as an example. Now we've set up our class. We have hydrated the class with the data that we've read off our local file system, whether that's CEOs or whether that is going to be world leaders. And we've done that based on the parameter that we passed into this init function, which was the path to that file. So we're pretty much done in terms of this section. The last thing that we want to do is just look at how the class gets instantiated. So just like in JavaScript, we've got the constructor. The constructor takes the data, and once again, we pass this same T generic, which originated all the way back in the init here, we passed that all the way through to the class. And so the class here extends the same leader file and CEO file, and then we can use this and say that we're using class data now. So the data that we're expecting on this class is going to be using that same TypeScript conditional that we can go and just quickly have a look at. That same one that says that if we receive the leader file, then we're going to have an array of leaders, and otherwise we're going to have an array of strings. So that's how this is being drilled all the way from the instantiation through the init function, or method rather, that static method below, all the way through to the constructor. And now this is how we know, based on the file type or the path to the file, exactly the type of data that we're dealing with. Finally, we've got this get stored data, and it once again has a return type of data which is based on the file type. All this does is just returns the data which is available in this class and which has been seeded into the class at the time of instantiation. Great. So now we've explained how this class is working, and we've explained how we've used conditionals in TypeScript to make a determination to the exact type of data which is available on the class. We can hover over it here, and once again we can see exactly that we're using that class data conditional, and that is how TypeScript is making a determination and allowing us to deal with both shapes of data. I'm going to step back into the promises file, and now we're going to have a look at that, and hopefully it's going to all make sense and come back and be quite clear. So let's go back to our promises.ts, and we know that we changed this method because I said that this method was a little bit unclear with respect to its naming. We're going to use get stored data. We actually don't need that. We only need to console table this. And so I'm just going to say get stored data. And now, one more time, just for demonstration purposes, if we say that we've got the world leaders file here, and we hover over leaders, we can see that we've got this API generic type which takes the world leaders. And if we go and we say leaders, and then we say get stored data, and because it's a getter, we don't need to invoke it. We can simply access it like a property. That's because we've used the get keyword on the class type. And if we look at the very first element, then we can see that we have the exact properties associated with world leaders because we've passed the world leaders file. Now, if we go and we say that this here, rather than the world leaders file, is going to be the CEO file. So if we say that's a CEO file, we're now going to get a warning because it's going to say that we can't access the name property on strings. That doesn't exist because now we're dealing with stored data, which in this case is, because we've passed the CEO file, is going to be an array of strings. So in this section, we've dealt with TypeScript conditionals, we've dealt with classes, we've dealt with validation and the is keyword. We have also used the async await syntax for promises, and ultimately what we've done here is quite a complex TypeScript exercise. So if this made sense to you, I am confident that you are going to be a great TypeScript developer and there's going to be no issues from now on. You can certainly take it to the next level after this course, but this has really given you the foundation that you need to understand TypeScript. Right back at the beginning of this tutorial, we installed TypeScript and we installed it globally. That was great because it meant we could just use the TypeScript compiler to transpile any of our code from TypeScript into JavaScript, inspect it, and learn about the language. Of course, it's also helpful when you've written TypeScript files and you don't have them in the context of a broader project. You may just want to use the compiler or use tsnode, which allows you to run the TypeScript files as executables and skip the whole transpilation step. However, when we move on from the end of this course, and really I believe you're ready now to start shipping excellent production grade applications with what you've learned in this course, we want to set a really solid foundation with our TypeScript configuration, because if we don't enforce good discipline at the beginning of the project, then it's very difficult to win back many of the benefits of TypeScript. We only get the benefit of TypeScript, as we know, when we adhere to being strict with the language. For example, when we discussed any and as type assertions, we want to use them as little as possible. The more that we use aspects of TypeScript or turn TypeScript off, in effect, the less benefit we get from the language. So, with that being said, let's go and create a project structure which is going to lay the foundation for your next TypeScript project and give you an introduction to the different options available with respect to your TypeScript configuration. So I'm going to create a directory, and that's going to be called Learn TypeScript. Let's go into that directory now. Of course, there's nothing in here, so I'm going to use pnpn. You can use npm or yarn to do this as well, and I'm going to initialize this project. Now, we've done that, and of course that's giving us a package.json. We're going to go there in a moment, but first let's set up our tsconfig. And the tsconfig is where we are going to set the configuration items for our TypeScript. One way that you can do this is you can first, let's install TypeScript into the project, not just globally, but we're going to have it available as a development dependency, because after all, this is a development tool. So we can do that with pnpm I, and then we want to save this as a development dependency, and so we're going to say TypeScript. Great, so that's installed. So now when we go to our package.json, you're going to see that in our dev dependencies here, we've got TypeScript installed. Of course, the same version, but nevertheless, when this gets pushed up into GitHub or wherever it may be, and your team works on it, you'll all be working off the same TypeScript version. So it is important to include it there, even if you have it installed locally. Now, next, we want to use that to create our TypeScript configuration, and the way that we do that, we say npx tsc using the TypeScript compiler, and we say init, and it's going to create a new tsconfig, and it's got a number of options in there. We're going to talk about them in a moment. So let's go into the tsconfig. Now, this file, certainly try not to be intimidated. Many of the options available in here are not relevant to every project. You can imagine if you're working on a React project, then you've got a lot of JSX or React specific options. If you're working on a node or serverless function or whatever it may be, then you have a totally different set of configuration items that you may want to apply. But what I'm going to rather do than go through every single item is I want to talk through a configuration that I would use if I were to set up a new node specific project. And what I'm really interested in is enforcing good code behaviors, and we do that through the type checking, which is the last section, or the second last section down here. And these are the options which are really, really interesting with respect to how the TypeScript language works when we're developing. Of course, all these others are still important, but it is important just to note that they have a time and a place. So let's just go in here. I'm going to simply put in the configuration that I would use, and I'll explain all of these different items. So the first thing that I want to point out is that we've got the target. Recall right back at the beginning, and also when we looked at enums, we transpiled our TypeScript into JavaScript, and we noticed that where we had const variables, now we had vars in the JavaScript. And what that was is that the target or the version of JavaScript that we're emitting from the compiler was an older version of JavaScript. So if you're working on a node project and it's a new project and you're going to deploy that maybe in a Docker container, and you've got control over the version of node that's going to be running, you don't need to be too concerned with having a really old version of JavaScript, an old target. The reason being is you have a lot of control over the environment that you're running your code in. On the other hand, if you are building an application primarily for the front end, and it's going to be rendering this JavaScript is going to be sent to the browser and is going to be consumed by the browser and your end customers, and you don't know what kind of browser that they're running, and it's possible their browser is out of date, then you may want to accommodate that with an older version of JavaScript. And the way that you would do that is you would change this, rather from ES 2020, you might say ES5, and you're going to go all the way back down to ES3. So we don't need to in this case, but just consider the context of your project, what you're trying to achieve, and in terms of the target. The next thing that we're going to touch on is the module. So I've set it as ES next, and that is the most up to date, and we want to use the ES import syntax. So if you're familiar with JavaScript and require syntax for requiring files or node modules or whatever it may be, then we also have the import syntax. We've been using it throughout this tutorial, the more modern syntax where we import, and it is generally speaking preferred by most people. So in this case, the module that we're using is going to be ES next, and it is the most up-to-date module version. Next, we've got the out dir, and that is the location where we are going to emit all of our code. So we have a source directory, which is provided down the very bottom here. So this is telling the TypeScript compiler include all of the files within this source directory and any subdirectories in here. And then when you are done with the transpilation process, emit it or output it into this dist directory. So before we get into some of these rules, which I've set, and these are really under code quality rules down here, let's just exit out and let's go and have a look at what we've got here. So we've got our package.json. That is obviously in the JavaScript world, but nevertheless important. We have our pnpm lock because we've installed TypeScript as a development dependency, and we've got our tsconfig. Let's look at it in a little bit of a nicer fashion here. So we've got these files. So what I just touched on there was in the includes, we have the source directory. So let's go and create that, and we're going to put an index.ts file in here. So we've got the index.ts file, and in here we're just going to say console.log hello world. So pretty basic stuff. Now what I'm going to do is I'm going to add a script into this package.json. So the first thing we want to do, we want to say type in here, and we want to let the package.json know that we are going to be using module syntax. This is just important if we want to get the ES modules working correctly and not misbehaving. Then in here we're going to say have a script called build, and simply that's just going to run our TSC, that TypeScript compiler that we've been running throughout this whole tutorial. The difference being that here we have this tsconfig set, and so it knows to look at that tsconfig and therefore apply the configuration that we've set in there. So our build will not just build to the location where the file is, but it will rather put it into this out dir here, and it will give it in the format, in the JavaScript version of what the target is. So let's just try that now. So I'm going to run pnpm build, and we can see that a dist directory was created here. It's got this JavaScript in it, and we've got hello world. So it's all working at the moment. We've got all of the aspects working. But now what I want to do is I want to delve a little bit deeper into these rules here. So you can imagine everything from line 7 down here is a rule with respect to TypeScript and the type checking. And this is a small list, but nevertheless really, I think, a great start with respect to your project. You can certainly expand on this, and I'd encourage you to read all the TypeScript documentation, but let's go through each of these and make sense of them. So I'm going to, over here, we're going to have a look in our index, and let's start to just demonstrate. So one of the things here, if we were to write a function, and we're going to call this congrats because you're very close to the end of this tutorial. So we're going to call this congrats, and we're going to just pass in some text, and here we're just going to console.log this text. Now, the first thing that you'll notice is that we've got this diagnostics warning, and if you've been following along, it should have bugged you that there was no type associated with text. So if in here we put in string, now that warning that there is an implicit any is going away. So in fact, this is an error. So if we were to run this here, then you would see that this has come up with an error, and it says that parameter text implicitly has an any type. So this error is actually failing to compile this code into JavaScript. The next example that I'm going to provide to you, so on line 7, is the strict null checks. So if we have this set to true, where we have a situation like this, where here I've declared an options type, and then we've populated options, and in the original type we have the status set as an optional item. So this field could be optional as designated by the question mark that we're familiar with. And so if we come down here and we try to access this toString, it's going to say that options.status is possibly undefined. So this is one way that we are forced to check. So what we could do is we could say put the optional chaining on there, which then says, okay, if and only if this is not undefined or null, then we are going to put it to a string. So that is the next option. The following one is use unknown in catch variables. So as I've mentioned numerous times throughout this tutorial, we prefer to use unknown over any. The reason being that any is the most flexible type, and by default in try catch we have some logic, and then in here we have the catch statement, and we have the error. And so here, if we set this option use unknown in catch variables and we hover over it, then we are going to be given an unknown as error. So the way that TypeScript works, or JavaScript, we don't actually know what is going to bubble up through here at runtime. That's why it's ordinarily given the type of any. It could be anything. But by making it unknown, we can still console log unknown. It's not going to give us any warnings there, but we can't say e.message. This is going to say this is not there. So this is then going to force us to check to see if that exists on the error. So that is an important one. And the next one is no unused locals. Now the next option is no unused locals. So by exporting hello world here, I've just forced the compiler to be aware that we've got some options that aren't being exported. Before that it was not catching this. But in this case, options up here is a type, and that's fine, but options here on line 6 is a value, and it's not actually being used or referenced anywhere. Hello world down the bottom, this variable is being exported, but options isn't, and so therefore we are given an error that options is declared but its value is never read. So this could be fixed by exporting it, of course, or deleting it, and if we remove hello world, we're going to get the same error. So this is great because this prevents us from leaving in variables that are not referenced, not used. They should obviously be removed. And the last option that I'll just touch on here is in the case of no unused parameters. So if we have a function, and then the text is here, but then we say console.log congrats, you will see that this text is never referenced, and therefore it's going to throw an error here. So much like the others, we can run pm build, and we're going to get an error. So this is the set of options that I would ordinarily use, and the next option I'm going to show you, we're done with the compiler options now, so we can quit out of all of this. And what I'm going to do is I'm going to go back into the package.json, and in the script I just want to show you the watch option that TypeScript offers. So we can say something like we want start dev, and this is going to be TSC, so we're still running that, but we're going to pass the watch option. And so now what happens is if we run pnpm start dev, we can see it's in watch mode. And this is great because now if we go to our source and we come in here, we can have a look here and we say fix this. We can provide an underscore at the start, and that is convention for saying, okay, this is an unused variable and I'm aware that it's unused. And now you can see down the bottom that these file changes have been detected, and so 0 errors have been found, and it has then provide the compiled code, and you can see that the variable with the underscore is now in the compiled code. And finally, for the purposes of development, what I've also installed are 2 additional dev dependencies, so Nodamon and tsnode. And what these allow you to do, or Nodamon specifically, and it relies on tsnode being made available, is that if you come back up here to our script, I have added this additional script, and that is start dev. So if we run start dev, let's run it, we see that our compilation starts in watch mode. So that means that our TypeScript compiler is compiling our code and it's watching for changes in our files, and then Nodamon is serving those files. So we can see here that the congrats is being provided. If we come in here, we can see that our function is being called and it says congrats, and then my own personal congrats, I'm going to just say you are going to be an incredible TS developer. And if we save that, then it's going to rerun the code. It's listening, it's then recompiling, and then down the bottom you can see that it has updated the text. So that is a setup that I would use to start a Node project on a really solid foundation. And of course, if you work with React or Vue.js or Svelte in the front end, or Express or Koa, or with any of the available frameworks, also with Next.js and so forth, then it's going to give you the opportunity to use an out-of-the-box configuration with TypeScript. But it's important to understand how the TS configuration options all work together, and you can customize them to your liking. And as you get used to the language more and more, you can start to use options that you think are really valuable. So that summarizes this section. So there we have it. We're at the end of this tutorial, and I hope that you've enjoyed it. I really appreciate you taking the time out of your day to go through all the material that I've presented here. As I said in the beginning, my intention was to give you the confidence to jump into any project written in TypeScript and not be intimidated by the new syntax that you might encounter. We've covered a lot of syntax, and while it's impossible to cover everything, I am certain that if you've understood a lot or most of the content here, you are ready to start shipping production grade TypeScript code. I hope by now the benefits of TypeScript are clear. When you're scaling your team or your project or your business, the type system that TypeScript introduces brings a lot of discipline with it. When it's used correctly, it means it'll be a better experience for you and your team members, developers, and ultimately should increase productivity. It should also dramatically reduce the amount of runtime errors. Overall, TypeScript addresses many of the issues that JavaScript has, and ultimately JavaScript will start to adopt, and already has started to adopt, many of the initiatives of TypeScript. But it would be remiss of me if I didn't touch on some of the shortcomings of TypeScript. There are downsides. Just like with any language, there is always a trade-off. When we think about lower level languages like C and C++, we know we get great performance, but the time in development blows out. While JavaScript, on the other hand, can be easy to whip up a quick application, it might be riddled with bugs and ultimately may require additional testing and may be difficult to catch all those bugs because of the lack of a static type system. TypeScript tries to marry these two worlds. But one of the complications and implications of this is that we do have to write more code. Really, TypeScript requires you to learn a new language. It imposes a lot of additional syntax. And so my advice is that where possible, use the inference system. While function return types can be very important to reasoning about the return type of a function and quickly looking at a function, understanding what it does and what it returns, there's other times where you don't need to type everything out. Some of the best libraries and frameworks like TRPC, for example, have a lot of the type structures baked in, and you don't ever or very rarely have to actually type out interfaces and type aliases. So although TypeScript does force you to write more code, by using the inference system and using TypeScript in an effective manner, you can reduce the amount of code that it requires you to write. The second downside is transpilation. We saw throughout this that JavaScript is the only language that can actually run in the browser. So even though we're doing all of our code in TypeScript, the shortcoming is we still have to transpile it into JavaScript. This additional step has brought some controversy at some points. For example, at one point there was a rumor saying that Svelte had dropped TypeScript. In fact, Svelte never dropped TypeScript, and SvelteKit, and Next.js and Vue.js, React, they all use TypeScript or have some level of support for TypeScript. And they will continue to do so. In fact, they will only get better with respect to their TypeScript support. But what the founder of Svelte actually intended and meant by this was that when you're writing a library and its transpilations from JavaScript, TypeScript has to do a lot of gymnastics and make some difficult decisions sometimes, which leads to spaghetti code, and this can be really hard to debug. So the Svelte team ultimately, for their code and the actual Svelte framework, decided on using JS docs, and we still get a lot of the benefits of TypeScript with their approach. The point is that there is a time and a place for TypeScript and a time and a place for JavaScript. But nevertheless, the fact that there is a transpilation process is a weakness of TypeScript. Finally, on that point, and the last major downside that I see for TypeScript is that there is no real safety. So don't have the false sense of confidence and security thinking that these types are going to protect you. Ultimately, we know that when it goes through the transpilation process, these types are lost. And so TypeScript is not a replacement for tests. Code can still run in that JavaScript. Functions can still accept strings and numbers and whatever it may be. It is only a development tool, and I apologize that I've mentioned that so many times, but it's important to drive this home because this allows us and encourages us to write better code, but it's not a replacement for tests. It doesn't exist at runtime, and therefore these types aren't being checked at runtime, so it's not validation. And so it's an important note that unfortunately the types don't exist at runtime, and so they don't actually provide real safety. Despite all this, TypeScript has seen a massive increase in its usage. So at the time of recording, about 46 million downloads per week, and it's only going to get more. As I mentioned, maybe one day JavaScript will adopt all of the many benefits of TypeScript, or at least some. But for the foreseeable future, TypeScript is the go-to when it comes to full stack development, and especially in the front end. But there is, of course, a lot of adoption in the back end with Node.js as well. If you've enjoyed this, please do let me know. Please give feedback and let me know if you'd like me to cover any frameworks, any other languages. I work across a plethora of different technologies, and I would certainly appreciate any ideas from you about further material. Thanks.